have you shown me part 3? I don't know what's part 3 yet, so you can show me later. Part 2 first. Now, if you can already do part 2, then we just skip lah. Can you do part 2?
I mean, I have the answer, but I don't know how I got there.
Right. Okay. So let's talk about it. Right. So what matters is that you understand lah. Right. Okay. That's physics. That's always been physics. My temperature goes up. This is the basic heat transfer that you learn. My temperature goes up because Q in bigger than Q out.
Yep.
And then my temperature goes down if
Q in is less than Q out.
Right. Now think carefully. Oh, sorry, I should have run it. Think carefully about the question situation. The question says, show that the temperature is 25 K, right? What he means is in average. He doesn't even mention that. So it's a little bit annoying for me. Average temperature. Obviously, the temperature on Earth is not the same lah. There's minus 50 at some area. Currently, we are almost facing 40 right now, 40 degrees. Yeah? But the average temperature is 25 K. Let's calculate what is that in Celsius. Let's just make sure that it makes sense.
253.
253 is very low, isn't it?
253.
That is very low, isn't it? So 25K minus 27K, he's taking that the average temperature, the average surface temperature of the Earth is 25K. Oh, really? Minus 20 degrees, really? Okay, I'm not sure about that, but let's see lah. Right, let's see. Okay, now whatever that means, now you think carefully. If the surface, if the temperature of Earth is, this 253K, is his temperature going up or going down or something else?
Down a lot.
I'm sorry, compared to what? Sorry, compared to what we're experiencing right now lah.
Yeah.
Yeah, but he doesn't clarify that this is average. So according to him, our hot, our high temperature with the polar side lah, this one, the average everything is going to be minus 20.
No way.
Which sounds very weird until you realize that actually the South Pole is very big. The South Pole is averaging around minus 30. Minus 30, yeah. That's the average, right?
Yeah, but the equator is so much
40,
more.
40, don't forget, at high...
And the seasons are...
There's seasons also. Don't forget, first of all, there are seasons. So there are temperatures, other places of the West regularly 10, 15, and that's not very near the polar. Don't forget that 40 degrees right now, which is super hot, is only at high noon. At night, what's the temperature? It's actually around 22, 23. So it's not as high as we think, if you average everything. You may not believe the minus 20, but it's definitely not very high, is what I'm trying to say. If you average
the statistic like this.
However, this is geography issue lah. This is hardly a physics issue. This one you have to take it from me first. You have to take it from me. Yeah, this is just the average temperature of Earth's surface. So I'm asking you, the average temperature of Earth's surface is 253, average throughout. Does this mean Q out bigger than Q in, or Q in bigger than Q out, or something else?
It's constant.
Very good. This is where Q in equals to Q out. There we have the physics. Okay. So what is the source of Q in? What is the source of Q in? The sun.
Light from the sun.
Right. So we will be using the intensity right now times whatever lah for the Q in. Now, what is our Q out? What is it? What is our Q out?
I don't know.
Right. So think carefully. This is where, back to physics lah. There are only three ways for a thing to lose heat and to gain heat. That's three. What are they? You know this since primary 5-1. There are only three ways.
Water vapor.
No. We're talking about the whole Earth. It's difficult to imagine, right? But then again, we're talking about your Your body also. There are only three ways: conduction,
Or radiation and convection.
conduction, convection. Now, for a thing such as big as Earth, is there any way to conduct out of Earth? I mean, out of Earth. Is there any way that Earth can conduct out heat? Is there any particular way to do that? You think yes or no? Your thinking is important here, really?
No.
But why? Let's just be very clear. Why?
I said no.
Conduction requires touching and
space is a vacuum.
Yes, nothing is touching Earth, so no conduction. How about convection? How about convection?
No, cannot. There's no moving air in space.
Yeah, correct. There's no
radiation
on the vacuum of space. I cannot convect. Okay. How about radiation? As difficult as is it to imagine, this is very difficult for us, by the way. It's very difficult. Radiation do not require any medium. So can Earth radiate out heat? Can or not? I mean, think carefully. How did the heat of sun reach Earth? Conduction? No. Convection? No. How did it reach?
Radiation?
Correct? By photon flying from the sun to us. Because radiation don't need any medium. Then Q in for us. The Q out is the same. The Q out is the same. Does Earth need anything to help him radiate? No. I just radiate low. That's the physics here lah. Okay? That's the physics. Now,
just radiate.
Stefan Boltzmann outside the black body radiation, no? That is what we need here, no? To determine the radiation of Earth out. Thus, your chapter 8 law. Can we go to chapter 8 right now to figure out the Q out? That is what I'm trying to connect here. That is what I want you to understand.
What's chapter 8?
You look at it. I still remember chapter 8. Look at it. There is a very particular formula when they talk about black body radiation. See, when they talk about how radiation radiate.
P equals E weird symbol AT power 4.
Correct. P, right? So I'll put in P. P is not Q, so I'll just put in P first. P is equal to weird symbol E, I think. E sigma, right? E sigma area.
Oh, the weird symbol is sigma.
There's no sigma. There's no.
Page 7, right?
I mean,
on page 6 or 7.
I'm not seeing your slide, but I'm referring to this formula, which is in your chapter 8, confirm 1.
All right, on page 6 is E weird sigma. It looks like a 6.
It's a sigma. That 6 is a sigma.
Oh, it's called sigma, right?
Which is the Boltzmann constant, which is a constant, so just plug in number. Just plug in number. Okay. You need to know what the P is, the area is, and that E is. You need to know that. Okay.
Wait, what is sigma again? Sorry, one more time.
Stefan Boltzmann constant, your slide say, which is a constant, no? Which is just given or just plugged in. It's just going to be like that, no? Okay, so that's the least of your worry. You should talk about the epsilon, the E thingy, the area, and the T, I guess. What will be those three? In the case of a big gigantic sphere called Earth, in case of again, looking at your slide, what is the E and the epsilon thingy?
Is a constant?
Yeah, just leave this. Come on, man. Just come. It's there. It's the slide is there. Slide.
Where?
Oh,
I thought you meant to look at the book. Wait, let me pull out the slide.
Looking at the chapter 8. Look at chapter 8 lah. You know, look at it. Look at it, man. Look at it. Well, I mean, you have the printed one. Actually, look at the printed one. Look at the printed one. I think that's better. But
I had the formula booklet. But that's about it.
You don't have the printed one. You don't have the printed one, and you don't have the digital one. At least, let's look at the digital one together. Look at the chapter 8. Look at chapter 8 lah. You know, look at it. Look at it, man. Look at it. Let's look at the digital one together. Do I have the digital one? I don't think I have. But, you know, if you have, let's look at it.
I'm looking for it right now.
Okay, nice. Let's settle that chapter. That was the first chapter we talked about, and it wasn't settled because we didn't do any question.
E equals 1 for the sun.
For the sun lah. Which is, so what is E again? Again, what is E? So because I don't think that's 1 for Earth. What is E?
It's the sun constant. Wait, no, it's not.
Come on, what is E? It's a black body thingy. Oh, come on.
E is the Stefan Boltzmann law. It's a value between 0 and 1. It's called emissivity.
Yeah, emissivity. That's the emissivity. So what's the emissivity of Earth? I don't think they tell you, but emissivity has something to do with the albedo. That's what I want you to realize. You can find the emissivity if they tell you the albedo. They are not the same. They're not the same. Does the slide tell you anything about that?
About Earth's emissivity? No, only the sun. Sun is 1.
Yeah, which is not very helpful for us here. Right? Like, seriously, your slide doesn't tell you anything about the connection between emissivity and albedo?
The answer sheet says the emissivity should be 1 also for this question.
The emissivity of Earth is not 1. Don't.
It says E is 1.
This is your answer key is bloody nonsense at this point, right? Can I? No, never mind. No. Look. Just look. I'm just gonna look for emissivity of Earth. Oh, go Google, educate us. 0.95. Wait, that's not. Wait, what? Sorry, I might be wrong. Wait, I might be wrong. Here. Maybe the answer key is correct. Maybe I'm wrong. Maybe. Yeah. Wait. Wait a minute. I apologize to the answer key for now. Okay? I apologize to the answer key. I thought the number should be lower. I thought the number should be lower. Okay. So if 0.95 is supposed to be the answer, then we don't care, we just use 1. Fair enough. Okay, so no, just use 1. No, that's fine. Fine. So we have the emissivity, we have the Stefan Boltzmann constant. Now, what about the area? Earth is a sphere, so the surfaces radiating is
the 4 pi r cube.
Yeah,
4 pi r square.
4 pi r square. It's not the pi r square, but definitely 4 pi r square. If you have no doubt, then you're correct. So we have the area also. Okay, the bulging surface mass. Now, the temperature, are we supposed to find or are we supposed to know?
Supposed to find.
Right. So of course, we don't know the temperature. The word show means we cannot use 253, right? We have to arrive at the number 253 at the end. So we cannot use the 253. Yeah. So do you have enough to start doing this part? Or maybe you want more hints?
Yes.
Yes. Yes. Yes.
So 2, 3, 4 equals 1 times a constant, which is 5.67 times 10 to the power of minus 8 times temperature to the power of 4. Therefore, temperature is square root 4. The 4 root 4?
Yeah,
root 4. Oh. 2, 3, 4 divided by 5.67 times 10 to the power of minus 8. Square 4.126 times 10 to the power of 9. Answer is 253.4.
Okay. Will this be okay? This should be the first time you try to use that formula lah. That's my feel lah. First time. And it is in this kind of situation where you should consider using it. It is a very different situation than most other questions lah. This is the situation. It's a very specific situation. So I hope next time you recognize the need to use this formula. That is what I'm trying to show you today. Will this be okay for part 2?
Yeah.
Okay. Now, what is part 3? Could you paste me something?
It just says state the assumption that was made in part 2.
Oh. One assumption. Only one.
Yeah.
Oh, the emissivity of the surface is 1 lah. That's definitely an assumption lah. It's not 1. It's not 1. Okay. Second thing, the 253 is the average temperature lah, throughout all the Earth, and equally distributed. Of course, that's not true at all.
The emissivity is 1.
Yeah, which is again is not 1. It's actually not 1. But I think I'm nitpicking. Okay, that might be my mistake. I was nitpicking at the wrong thing.
Okay.
Okay.
Yep.
Yeah. Hopefully we can do more paper next time, and when you encounter this intensity question, it will make more sense. Now, what should the next question be? Are we done with all?
The next question is 6, right?
Right. Could you please, paste it for me?
Where is it? 6? Let's check WhatsApp.
You say 4, 5, 4, 5, 10, I think, or something like that. But whatever you cannot answer.
Q10.
10.
Sorry. Do you have question 10 with you?
I do not have. Wait. No, just check.
No, it's all in the PDF. What?
Oh, it is. Sorry. So let me go. Okay, please read the question, and
This is stupid chapter 12.
What is chapter 12?
The whole nuclear physics.
Oh. Some are not as bad. Some are. Okay, let's do this. Now, the moment they say work function, I was explaining work function is a very fancy word for something simple. Do you remember? What was the context?
Mhm.
If you don't remember, can I remind you?
Sure.
Look at wait, what? Where is that? Look at yeah. Look at page 4, please. Look at page 4 of the same Jamboard. Where do we use the fancy phrase work function?
Kinetic energy.
Hey, come on. The topic is
Photoelectric effect.
yeah.
Okay.
How do I explain it to you back then? Better remember. It's very simple. In terms of energy, how do we see photoelectric effect? I hope you're looking at page 4, yeah?
Levels.
Okay, first of all,
So,
explain
yeah,
to yourself again what is photoelectric effect, yeah? I insist, yeah? You don't get this one, you don't get this. What is the input?
So the input is the
Form of the
energy used to raise to excite the electrons.
What is
to
the input energy?
bring them out of the metal?
I know. What is the input energy? It is a
Depends on.
no, doesn't depend. No, there's
It's
only
a-
one type in
It's a
photoelectric.
wave.
Yeah, a photon.
UV radiation or
It
photon.
doesn't have to be UV, but it has to be a photon. Can yeah? A photon, yeah? UV is photon. Huh? So the input energy is photon. How do they use the input energy? They use it in 2 ways. Explain to yourself.
First way is to excite the electrons to
The fancy word is to
get out.
get out. The fancy
Excite
word.
them.
No, exciting means it's not getting out.
Oh,
Exciting means it go up and go
to
down. The fancy word for getting out.
I should remember this.
Yeah, you should. It's a more common phrase. It's a more common phrase actually. I'll tell you first. Sorry, it's that time.
Remove.
Ionize.
Oh, ionize. Yes, ionize.
I hope that makes sense.
Ah.
So that's the first thing they use the energy for, to ionize. Then number 2, then they use it for you okay? Daniel? Then they use
ionize, then it shoots out.
yeah.
Boom.
What energy?
What do you mean, what energy?
Yeah, where it shoots out, it is look. The input is photon energy, right? Light energy. Then they use the energy for number 1 ionizing. Then number 2 shooting out fire. What energy is number 2? What kind of energy is number 2?
Light. I don't know.
It's a kinetic energy of the electron. So the one shooting out is an electron. So there won't be any light energy. The light is being absorbed, used for number 1, ionizing the electron, and then the electron go out, kinetic energy. The speed of the electron.
So, the kinetic energy.
Of the not of any photon. Okay, photoelectric.
Of the electron.
The concept is electron in, photon out. Just cancel that concept, please. It's the opposite.
I thought it's photon in, electron out.
You are correct. You are absolutely correct. Just now, however, the part 2, you say the energy of the photon. That's, no, it's the energy of the electron in the form of kinetic energy. You're right. Okay. Now, work function is a fancy word for which one?
The kinetic energy.
No, the other one, the number one. Yeah, that one you have to memorize. I understand, but please memorize lah. It's a fancy word they like to use. But it's telling what is the work function of the metal. Does that sound like it's gonna be, part one ionizing or part two electron flying out? Which one does it sound like?
Part one.
Yeah. So work function is the fancy word for part one, the ionizing part. Okay. Let's go back to the question. So what does the question say? The question say the work function for calcium metal is 3.2 eV. Does that make sense now?
Yeah.
Okay. Gamma ray is direct clean calcium metal. Does that make sense? Photoelectric, does that make sense?
Yep.
Calculate the maximum kinetic energy, blah, 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 blah. Does that make sense? Okay. Preferably, you can follow. If you have trouble,
this would be chapter. What chapter is it? 12 or is it 7?
Yeah, I just explained everything you need in page 4. So, yeah, I mean, you can refer to chapter 12 lah. But
Page 7.
I mean, the Jamboard is there, page 7.
So E equals HC over
Okay.
H is a constant.
Yeah, those two things are constant, right? So, I mean, you know them, lah, right? You know them.
The wavelength is 10 to the power of minus 12.
Right.
Okay.
Okay, there is this energy. What kind of energy is this? Which part of the process is this?
Part 1.
What do you mean by part 1? Sorry. This is the energy. Whose energy?
It's the ionization.
The ionization energy. Are you sure?
Wait 2 minutes.
Please think about photoelectric. Please look at page 4, please. That's what you're lacking, not the formula. Okay, Daniel, energy in, energy out. Photoelectric effect, the energy in is the
This energy in, right?
correct. You're correct.
So part one, I seen ionization
Oh, you bloody nonsense. You bloody nonsense.
is
Okay.
is
Energy,
ionization or energy in.
the energy in, correct this one. That's not the ionization energy. The energy in, the
Then
in
what is energy in?
is being used for what? Is being used
For
for
ionization.
just complete. Is being used for ionization and oh, you don't get it, isn't it? Hey, it's the metal. Go in 10 joule. Okay, go in 10 joule in the form of photon. What goes out is electron. First of all, the electron is a bit deep here. He ionized, that's the ionization, see, to the surface from deep 2 joule. And then he flies around with the remaining 8 joule. Ta-da! This is photoelectric effect.
Oh, okay. So the total energy.
So this guy is the total lah, total in, total out lah, correct? No, both lah, total in lah. Let's say, oh, that's the total in.
Is the ionization plus the electron out. Also, just minus off the ionization.
Yeah lah.
Then
Yes. Yes. Correct.
Minus off the work function.
Yes. Now you understand.
Yeah.
It's simple if you understand lah. It's not if you don't lah. Now you still have to deal with the EV. How are you going to deal with EV? You have to learn how to deal with it.
Convert to MEV.
What's your preference, from joule to EV or EV to joule? I mean, you can do both lah, right? But you know, check the question.
They want it in EV.
So better do that particular.
I hate converting. Okay, let me convert. Just convert. What's the conversion? Oh shit, I did memorize. Okay. Yeah.
To find out how to convert it, you have to, yeah.
Memorize MEV. Oh, I did. I wrote it down. Okay. I don't have to write it.
Do you know how to convert?
Yep.
Okay, okay.
Let me just start this 13.
Yeah, a very big EV. Oh, but it is. Oh, but it does make sense. Now, yeah, the EV of gamma ray is crazy big, so that does make sense. I'm not sure it is that big, but definitely big. Yeah, true. The work function of the method doesn't compare. Just make sure that everything is big. That is correct. Anyway, in this case, just check the answer here.
Okay.
Okay. So answer key correct?
Okay,
good.
wait, they have it to 2SF.
Oh,
Because of the rest of the
following
question.
the 3.2, yeah, following the 3.2.
All right.
Is the first time you kind of understand photoelectric effect? In a sense that it is not complicated at all. It is actually rather easy to understand. You will need it for other questions. That's what I'm trying to do. You okay? The concept?
Yeah.
Okay, let's hope you can use it again. Now, part B, no relationship to part A lah. Goodness me. Oh, goodness me. I've never explained most of these things. Now. Do you understand what part B is?
Just stare at it for.
Tell me your question, yeah? Tell me how much you understand, how much you don't.
The de Broglie wavelength.
That's the part where you don't understand, Ken?
I'm sure it's somewhere.
Let me confirm it as a simple understanding. It's probably not easy to accept, but it's very simple. So meson is a particle and not a light. That much is that okay, but
Yeah.
right. At this point, you are ready to accept that photon have wavelength. Yeah, like light have wavelength. What correct? What? Can yeah? Right. What this particular part is trying to ask you to accept is that particles also have wavelength, especially when the particle is extremely small. Meson, I don't know how small, smaller than neutron and proton. Those small particles will have very pronounced wavelength, even though they are particles, so they do wave around. You can accept that?
Yeah.
If you can, the Broglie wavelength of meson has a very simple formula. That's the good news. Find the formula. I don't see it in Anyanya's slide. Anyanya's slide has SL. So I'm guessing that in HL there will be. It's a very simple formula. If you cannot find it, share the screen. I'll find it for you.
What chapter again? 7?
Probably after photoelectric. What is the photoelectric chapter?
It's in 7.
Then go to the photoelectric chapter, not the quantum one. Search under the photoelectric chapter, the Broglie wavelength, you'll find it one very easy.
On it.
Okay.
It's in chapter 12. Surprise.
Surprise, surprise. Sorry. Apply lo. Simple frame.
Wavelength equals h over p.
Mhm.
Oh, p is momentum.
Momentum of the
Wait.
particle lah. The particle has mass.
It's not in the formula booklet.
What do you mean by it's not? No. The
This
wavelength.
formula is not in the formula booklet.
What? Sorry. What is not in? Sorry. What is not in the mass? The booklet.
This formula.
You need it. Memorize it, but
I know.
you will be needing it in a very specific situation like this. Very specific. It's not a major formula, but it cannot be replaced. So I mean, I guess memorize it lah. Do you have at this point, there's so many things I told you to memorize, right? It's easy to forget. Do you have a physical print of the formula booklet?
Yeah, of course.
Add this guy in your physical print, no? Add it in right now lah, right now. Wherever is suitable, don't put it. You place it wherever you think is suitable, so that next time you just refer to this, and you'll memorize it every time you refer to it. Don't worry. Don't waste time searching anymore. Put it in your physical print, treasure it, don't lose it, right? And let's apply lah.
Okay, let's do this.
Okay, can you use it here because you need to find the momentum.
Momentum should be easy enough to find.
Which is momentum you will require? What do you require for the momentum?
E equals m. Oh no, ek, kinetic energy.
Momentum
No.
it's not. It's
No,
energy, but it's not.
No.
It can be found from the kinetic energy. It can be, but it's not lah.
Yeah, I know.
Okay. Let's see. Yeah. I mean, okay, sure. You can use that. Fancy way of finding it. Fancy, very fancy. Sure. Nice. You can do that. Sure. Very fancy way.
Okay. So therefore, find the wavelength should be h. M is Wait, I didn't think this through. MEV c squared mega electron volt over c squared. I need to convert it to mass.
Do you?
C squared to kilograms divided by 9.3. Okay.
It's absolutely very easy to convert it to. Can I just show you? Can I just show you that this? I mean, it is weird for mass to be given in mega electron volt over c square, right? It is weird, right? It's not given in.
Yeah.
And yet it is given explicitly for your benefit. I hope to, I hope to show you that lah right now. Instead of a burden, it is a clear benefit. To me, it is lah. Again, let me show you. You want the momentum, right? So at this point, the momentum is 2 times the mass, which is 140. The mega is 6. And then this strange unit called EV over c square. I'm going to leave it there for now. And then times the energy. The energy will be 1 giga electron volt, correct? So 1 giga electron volt will be 1 times 10 to the power of what? To the power of? To the power of, sorry, giga?
9.
9, yeah, correct. Giga is 9. You do have to memorize that. And then EV also, okay? I'll put in the unit lah. All this square rooted lah, right? Very conveniently, I would say, this is E 10, 15, right? 15 EV square over C square, right? I mean, rather convenient, wouldn't you say? If I put it that way,
I guess.
Easy to use, right? In terms of unit, right? So this 0 will be 16. Can I pursue that with you?
Hey, where did the
Am I miscalculating? Did I, discount something? Did I leave out something? Did I account for everything? Yeah, just to confirm. Am I making
2 times m times ke?
Yeah, here's my
ke is 1 times 10 to the power of 9. Right?
Yeah, because he say the meson has currently an energy of 1 GeV. I assume that is all the kinetic energy. I'm assuming, I'm reading the question and assuming, correct? But he said accelerate.
What's the 10 to the power of minus 10 to the power of 6 again? Oh, m. Okay. M EV over c squared. Okay, but we need to find c squared and we need to find...
No need. Stop obsessing with c squared. Stop it. Really.
What?
You unpack the c square, you are saying I don't want benefits. Okay, I believe that's a mistake in exam situation. So first of all, I just put the c square, I just let it be on strides now, just let it be. I also have EV square and I have this and I have that. Can we confirm all this first? I'm simplifying for you. Yeah?
Yes. Okay.
Okay, so first of all, I have 10 to the power of 8, isn't it? I have EV and I have over C, taking it in strides, who cares, right?
Okay.
I also have square root 28, which I may say is 2 root 7. I don't know what's the real number. That's the number, whatever that number is. I'm not really sure I care right now. That will be my momentum, correct? Which, let me repeat, I don't care that momentum unit is not supposed to be EV over C. I take it by faith that it will be correct. By the way, it is correct lah, by the way, just saying. But I'm not...
Just believe.
It's just EV over C. Who cares? I am taking the benefit that he's giving me right now by not caring. Just do it. And so far so good. And one more time, I don't care about the C.
Okay.
Yeah, so I have my P lah. Now let's see whether I can stop. I should stop carrying now, or I can carry over my benefit. Okay, I want my P ma. So my P will be used, lambda equals to H over this P lah, this thing lah. So the H is 6.63 times 10 to the power minus 34. Can I confirm the unit of H? Is it somewhere in your data book lah? This determines whether I can stop carrying or not lah, right?
The unit of H.
Is
H is 10 to the power. Wait, unit of H.
Unit. This determines whether I should stop carrying.
Joules per second.
Oh, that means I think I have to start to care lah. I have to lah. Because joule over second is very SI. Okay, very nice. And this is not SI lah. So at this point, I think I have to care lah. I think I have to care. Furthermore, I have to change the EV back to joule somewhere. So I have to care about the C, and I have to care about the EV changing to joule, right? So how exactly do I change EV to, well, it's not joule, right? So to change EV to joule, correct me if I'm wrong. I'm dealing with the EV right now. Times, this is 1.6 times 10 to the minus 19 lah. That's me changing EV to joule, right? So I have to care about the EV, right? It is.
1 EV is 1.6 times 10 to the power of minus 19 joules.
Yeah. So that's me doing it lah. Okay, carrying the EV. Now I care about the C, which is very conveniently in your data booklet. Is it 3 times 10 to the power of 8, or is it something more accurate than that?
C is 10 to the power of 8.
2.9
meters per second.
Which one is it?
3.00.
Oh, 3.00. Then 3. Okay, I'm a bit surprised. I thought it's 2.97 something like that. 3, yeah. 3. So that's me caring about EV and C and converting them to SI lo. That's it lah. Okay, I just work this out, put this in, and then I will have my answer lo. Because unfortunately the H is in SI, so I have to care lah. I have to care.
Okay.
You okay?
Yeah, better now.
So yeah, I didn't care prematurely. I care when I need to care. If I can carry on the benefit, I don't care. Why should you care? My life is simpler if I don't care. So to speak lah.
Yeah, I guess.
Okay, but when I
don't really
care,
see.
I care.
Yeah. Okay.
So I'll recommend that also. Please check the answer in the end. Please check. This is correct or not. You still have to explain why.
Yeah, it is 2.3 times 10 to the power of minus 15.
Okay.
Uh-oh.
What's wrong? I mean, it looks about right. What? Minus 34 and minus 19, right? This is minus 34. Down here is minus 19 around there lah. That looks about right. What? Okay. This looks about right already. What? We're at the roughly the ballpark lah.
The square root for them is
Oh, they start to care very early. They start to care very early. I don't recommend that. Please, I don't recommend that. Look, do their number and do your number. Do my number here. Just do both. You compare lah. Just press your calculator lah. I mean, if both give you the correct answer lah, if both I think their method is slightly more complicated, but just because they care earlier lah, just because. Nothing wrong with that, but
the answer is 2.3 times 10 to the power of minus 15.
yeah, would you just please do this one? This one? Right? We haven't gotten to the final answer, right?
Oh wait, yeah. Sorry, I thought that was the final answer. Wait.
Yeah, yeah. It's not. It's not.
Let me just get.
Though it does disturb me a bit, though. Though it does. Because this is in the region of minus 19, not minus 15.
6.63 times 10 to the power of minus 34 over
this chunk of number.
that 2 through square root 7.
Oh, I'm very sure that we are at this point. I'm very sure. Yeah, very sure.
Times square root 7 times 2.6 times 10 to the power of minus 19 times 1 over 3. Yeah, it's correct.
So both gives you the correct answer lah. You decide which one is better lah. Whatever is better, you do it lo. But do practice it a bit, yeah.
Okay.
Decide for next time. Should you care early or should you care later?
Don't know.
Decide later. Decide next time. No? Should you care as early as possible or should you care as late as possible? Okay, good. Now that's part B lah. I think we have 10 more minutes. Unless you're going for 2 hours. I like you today. Yeah? Today you're like the normal Sunday. Like you today. Okay, half-life is okay. We'll just ignore that, Ken. Yeah, this should be new. So in the Jamboard, I put the bismuth part lah. So do you know how to do half-life section? This is where, yeah. Do you know how to do it? It's not complicated if you understand. If you don't know what's going on with the decay constant, the decay constant is important. Would you kindly refer to your, to your slide first lah, right? There is a decay constant there, and they tell you the relationship with half-life.
Definition of half-life.
No. Let's not do that. You do that yourself. Can please definition we skip. Can?
Oh wait.
Can we just skip that?
Calculate the half-life.
Yourself. Okay. Let's do the calculation. Let's do C. I.
Or I.
I don't know. Calculate the half-life.
Oh, this. Yeah. T half is equal to 1, 2 over yeah, okay. Which is
On that connection, so far so good lah, right? So far so good. Oh, this question is not the best example. Fine. Let's talk about the part 2 lah, right? Okay, so now still a good question. The first part, this one, this sentence lah. This part makes sense to you or not?
Which part?
Board page 8, right?
So yeah, it's the half. This will be 2 half-lives.
Yeah.
It means the half-life is 1 hour.
Yeah, kind of 1 hour. Yeah. So after 2 hours, 1/4 n. Does that make any sense?
Yep.
Okay, good. Now, then he tell you something slightly new. Actually, bismuth 212 and thallium 208 is connected. Bismuth 212 becomes thallium 208. That's the new thing lah. I didn't know that, so they tell me. Okay, nice. That is the meaning of this part lah. So far, so good.
Yeah.
Now, the next part needs to make sense also. He say the number of thallium, which is the product, is not 3/4 n. It's actually less than 3/4 n. First of all, does that make some sense, this 3/4 n number? If it doesn't make sense, we need to talk about it.
Can you repeat that again? Sorry, one more time.
Bismuth Bi lah, 212, right? Sorry, 212. After 2 hours, right? I have 1/4 left, right? Now, pray tell, what happens to the 3/4? According to you, what happened? Not according to the question. What do you think?
It's decayed.
And the word decay means what happens to the bismuth 212? Very likely, what happened?
It becomes thallium.
Okay. Just to say, they don't disappear, right? Okay. So now, there's your 212.
Like I said, decay in this case is like it loses an electron.
Not necessarily electron. You can lose, you can lose.
It loses something lah.
You can lose alpha lah. You can lose something usually, but it does lose something usually. Correct. It does. So usually it becomes, a thinner lah, which is 212 to 208. Yeah, okay. It becomes thinner. Makes sense. What happens to the what happens to the bismuth that decays? It changes to thallium. Okay, thallium. I don't know what's thallium. 208. So the question specifically mentioned the number 3/4 n. Does that make sense?
Yeah.
Okay, makes sense? Because there you go lah. That's your 3/4 n. Or 3/4 n would have changed to thallium 208. Correct? That's why they bother to quote that number. Okay. So he say then, it's not 3/4. It's much less than that. Much less than 3/4. Right? Suggest a possible explanation. No? Now that is the real question. Can you understand the question? Do you need a hint for the answer?
Thallium has a shorter half-life than bismuth.
Much shorter. What does that mean then?
Then, like, even though the bismuth decays into thallium. The thallium decays faster.
Yeah, therefore, much less than 3/4. Done? Good.
Yeah.
Good. You got the logic lah. They like to change this kind of thing. Now, is there a part 2 or something? Did the question end there? Because in your PDF,
There is more.
oh
wait, no, that's the last one.
Yeah, I don't understand why they like cut off there lah. Like, is there something else?
Nope.
All right. Okay. So, not the hardest question, but not a joke either. As you can tell, you have to think a little bit lah to understand the question, right? As per usual, once you understand, you get it lah. The difficulty is the understanding part. All of the question that you ask me, half of the issue is understanding the question itself. Right? Another half is the concept. You have some gaps. So what I'm trying to say is I'm very happy that you asked these questions. I am hoping that that will help you lah.
These are my least confident questions.
Sorry, you're saying?
These are my least confident questions.
Fair.
That's why I asked.
Fair. That's fair. The topics are there, and that is the right thing to do if you aim for a final 7 lah. That means you cannot ignore any particular topic lah. If you're aiming for a final 5, I wouldn't care. You shouldn't care also. But you're not. You're aiming for a final 7. So yeah, you are carrying quite early lah. As far as a guy is concerned, you are not as late as some other guys lah, I would say. Not a praise though, yeah. It's not. Now, glad that we caught up with all the questions. Now, what shall we do next? Because I want to have a few more extra classes, not to catch up lah, but to do more. Now, to do more.
Let's do math.
Oh, no problem. We haven't been doing math, right? We haven't been doing math. But that means that I shouldn't ask you extra class tomorrow lah. Shouldn't, right?
Tomorrow.
Yeah. I mean, if I ask you tomorrow, maybe you have not done any practice. That's not good lah. Right? So again.
Yeah. No, I'm going out to study tomorrow. So, but tomorrow I was planning to study chem.
Chem is fine. No, go and study. You can ask chem also, yeah?
I can squeeze in a bit of math.
No, not a bit, not
Actually,
a bit. Just give another day for math, and then we do your class. Let's do that.
Okay.
So what it means is this. I think throughout these 2 weeks, we have still around 2 weeks left. We do 3 extra classes. 3 extra means 3 times 1.5. Okay, not 3 times 3. Okay, 3 times 1.5. Okay. Let's decide when to have them so you know when to start. Also, let's talk about the Tuesday and Thursday one, because in holiday, it's not necessary to split them to Tuesday and Thursday. You are reasonably, you're reasonably awake. You can decide what day to use them. Then you can know what to study before those tuition. You understand? You have 5 times, no, is it 5? No, you have 6. You have 6. Again, you have 3 extra 1.5, right? That's what I'm asking for, extra. And then you still have another 3 1.5, which is the normal one. 1 for this week, 2 for next week, correct? So you have 6. Can we place them strategically?
The next 2 weeks.
For these 2 weeks, Can we place them strategically, synchronizing with your study schedule? That will be much better. Now, you decide. If you cannot decide, I'll decide. But I don't want to decide. Okay, you have your schedule. You have your study schedule. What do you think is best?
Okay, come let's plan this out together.
We'll go to the Jamboard. We'll go to the next Jamboard. Okay, we'll go to the next page Jamboard. Okay, I'm drawing the just a simple table for you, right? Okay, Sunday, right? Monday, Tuesday. We are here lah. We are Tuesday, right? Hey, wait, we are Monday. Let's go. Right, Monday, Wednesday, Thursday, and I don't do Friday and I don't do Saturday, right? I don't. But you can study on Friday and Saturday. We have another Sunday, and right before school start, another Sunday lah. Okay, so this Sunday confirm 1.5 hour. Can I say that? Confirm already lah. We have to use it 1.5 hour. Okay.
Yep.
Okay. So the Sunday one is clear. Okay. Other than that, nothing much is clear. No? Nothing much. Okay. If you could place it for me, that would be ideal.
So we have tuition tomorrow, right?
By right, but if it is not a good time, I want you to push it back a little bit. But if you want to tomorrow, I'm very happy to see you. Remember, there will be the 2 p.m. slot. You can always arrange the slot, the 5 p.m. slot, and the normal night slot. This is holidays. You have to place 5 more slots. That will be maximum, right? Let's try 5 slots, but let's just try it.
Okay.
Let's try 5 slots effectively.
Shall we say 17th?
17 is where? Sorry, what is 17? This is 12, right?
Saturday.
12, yeah, okay, 13, 14, 15, 16, 17, yeah, 17, right? Sorry, yeah.
14 to 16 are not free.
Off limit for me, not for you, yeah?
Okay, so 17th. Yeah, sure. I was planning on doing a camp paper on the 17th. Maybe I can do it in the morning, then go through with you.
Sorry, you're referring to 17 Saturday, right?
Yeah.
Saturday and Friday is off limit for me. I cannot do Saturday. Doesn't mean that you cannot study on Saturday. You can go through it on the Sunday.
Yeah.
That's nice. That's nice, right? Are you saying that you want to talk about camp on this Sunday? Yeah, something like camp. On the night of Sunday. Is that what you're saying?
Yeah.
Sounds good. Sounds good to me. Okay.
Sunday we can do double session. I think.
We can. The only time we cannot do double session is Sunday lah, because church and everything, right? That one I cannot. But the rest of the day I can do double session.
19th Monday can.
Monday. So
2 p.m.
slot. Are we talking about 2 p.m. slot? That's 2 p.m.
Yeah,
and
19th.
And then the night also. You want the night also, is it? You don't have to do
19th. I can only do 2 p.m. on 19th.
Yeah. Good. Any idea what you should be talking about here? I'm ready for anything, but you should.
Physics.
All right, physics. Right. I hope that means you have practiced, more lah. Right? Okay, good. We have one. Right. Good to know.
Okay. Let's see what else. 20th. We can do 7:30 to 10.
7:30 to 10 sounds ambitious. You want that really?
Unless yeah.
That's a bit
good idea.
Yeah. So maybe for you maximum 2 hours. Maybe for you. It's fine. 2 hours. 1.5, 2.5, maybe not. Maybe not.
I think maybe 19th and 20th we both do 2 hours.
Okay, 2 hours. Right. But what time are we talking about here?
So 2 to 4 on 19.
So I'll say 7.5 hours. So currently we have correct 7.5. Right? So but okay. Sorry. For 19, can I make a request? Because I already scheduled the Monday. Yeah, Monday. If I think the Monday is too crowded at 2 p.m., can we shift it to 5? Is that okay for you?
No, I have tuition 5:30 to 7:30. But I'm free the whole morning. So I'm free the whole day up to 5:30.
So maybe earlier, I'll just put it, if I don't think it's a good idea, we'll shift it earlier. Something like that. Make sense?
All right. So tentatively 2 to 4.
Okay, 2 hours lah. Okay, great. Now at 20th, you're talking about the night slot, 2 hours, right? Night.
Yeah.
Okay.
So make that 7:30 to 9:30.
Makes sense to me. Now, what do you want to study?
Math.
Yeah, right. So you know what to study before that. Okay. Oh, that's easy, right? We are supposed to put in 7.5 hours, and you're already using 4 hours already. Okay, sounds good.
22nd, you can.
22nd, right? Okay. Any practice? This one I'm freer, right? I'm freer. Maybe you can do
2 p.m.
2 p.m.
Evening, I should have something on.
Right. So I also hate evenings for you Thursday, right? Okay, 2 hours. Is
2
it?
to 4?
2 hours.
Yeah.
Okay, and what should we be studying?
I was going to do chem, but I think let's do physics. Physics.
Sure. But not a lot of math, eh? Are you sure about this? Not a lot of math here.
Yeah, do more math. I feel like I'm going to run out of like practice papers. So.
That's not a problem.
Unless you have any
problem. No, that's a good problem. Unless you run out before tuition, right? That's a good problem. Don't worry.
Yeah.
As long as you haven't run out, keep using them. That's good. That's really good. Okay. Now, let's say it's physics. Yeah, let's say it's physics. So you have 6 hours. Shall we use 1.5 hours on this Thursday, maybe? Sounds good. That would
say again, sorry.
So because 2 hour, right? Looks good lah. Looks good to me. Why not we use 1.5 hours here, which is here as in this Thursday, this Thursday, which is what day is that? That would be 15.
I'm not free the whole day.
That means have to be earlier. Wednesday. Okay. Wow, Wednesday. Does that make sense to do it on Wednesday?
I'm also not free. Wednesday to Friday, I'm not free. I got stuff on. I think maybe Friday I'm free, but you're not free on Friday.
But here's my concern. If your Wednesday and Thursday is not free, then what are you going to bring in on Friday? I mean, I can make some exceptions, but you know.
Friday is your off day.
I mean, I can make exceptions for a 1.5 hour slot. That's still okay lah if you are prepared. Prepared means you just do something first. If you come in blank, then I also stare at you, you stare at me. The issue is less of me than your schedule. Wednesday, Thursday, you have something on. Then what's going on with Friday? Like, for example, Friday should be math, right? That makes sense, right? I mean, you have to touch math a bit more, but can you do math?
16.
That would be 16.
Yeah, okay. 16, I guess I can do in the evening. Afternoon? Evening?
5, let me think. Friday. Tentatively, 5 p.m. Look. Does that make some sense for you? Okay.
I think I should be free after 3 p.m. So 5 works. Okay.
Right. Yeah, again, but this is supposed to be math, right? This is supposed to be math. Like, does it sound like the best time to do math because of your Wednesday and Thursday?
Yeah, I'll be doing minimal work Wednesday and Thursday.
I'll put math here first, and then I'm asking you to reorganize lah. Maybe look at your spread. You know, it's nice. What 2 math, 2 physics, 1 chem. It looks nice. Looks nice to me. But maybe you want to shake things up. You know, reorganize a little bit. Make it, you know, makes more sense. You know.
Okay, wait. Tomorrow, what are we doing again?
Tomorrow, no, there's no session tomorrow. I mean, we haven't.
13th.
We haven't scheduled anything for tomorrow. We haven't.
Tomorrow's Tuesday. We have tuition every Tuesday and Sunday.
Oh, no. Okay. So again, I told you the Tuesday and Thursday 1.5 hour. I just put it here. Just put it here. I just put it in a pool. Same
But
thing.
just assume, no, like tomorrow, what are we doing? We do math tomorrow?
No. I put the tomorrow's 45 minutes, right? Remember? 45 minutes. Normally lah, normal school day, because school day very busy. I put them in the pool and ask you to redistribute. It doesn't have to be tomorrow. But if you want it to be tomorrow, it's available for you.
Yeah, let's do tomorrow.
Then tomorrow 1.5 hour lah, for example. Am I correct?
Yeah lah.
Okay, but what do we do tomorrow?
I think if it's possible, can we push it a bit? Instead of starting 7:30 to 9, we do 8 to 9:30.
I think tomorrow is okay. Still okay.
Okay.
So let's say instead of Friday is tomorrow lah, right? Instead of Friday is tomorrow 1.5 hour.
Mhm.
Okay, so 8 to 9:30. But
Yeah.
what are we going to do tomorrow?
Let's take a look at the spread.
I mean, you are going to do chem tomorrow. The one that makes sense is chem lah. What else is there? Correct.
Yeah, sure. Chem. Let's do
Okay,
chem.
so let's put chem tomorrow. That means this chem will change lah. So this won't be chem anymore lah, right? It will be math. Something like math. Okay, that Sunday math.
Which one? Okay. I'll just run through because I'm doing this on my phone.
Right.
13th,
The chem one, right?
13th Tuesday chem.
Yeah, 1.5 hour.
And the next one after 13th will be Sunday 18th.
Yeah,
right?
yeah, 1.5 hour math.
1.5 hours math. Okay, chem.
Then Monday,
Just making notes.
right?
Monday physics, yes, 2 to 4.
Yeah.
Then Tuesday,
Tuesday,
2 hours, 7:30 to 9:30 math.
and then Thursday.
Thursday math. Wow, that's a lot of math.
No. Thursday is physics. Right now lah. Right now.
Okay, so 22nd is physics. Let's put
Yeah.
that.
I mean, it feels like a good spread. I would say lah. It does feel like that.
Alright, that works for me.
Okay. So next week you'll study more. You also prepare more, no? Correct.
Chems.
Correct. You're in no danger to run out of papers next week, right? Just to confirm.
I might be, honestly. For math, definitely I'm running out already.
By the
In
next
fact, I think I'm out.
by the next Sunday, would you run out?
I can ask my teacher for more papers.
That will be a better source than me lah. That will be a better source. I mean, your teacher should be happy to give, I guess, right? Okay. All right. If we're happy, I'm happy. I'm happy with today. I'll see you tomorrow then.
Yep.
Bye-bye.
All right. See you.
See you.
Hello. Hello.
Jonty, I can hear you. Can you hear me?
Yeah.
Right.
Okay,
Cool.
so today are we doing OCam again or how?
No. Last time we met, we are already,
We are
trying
doing the questions.
for the paper. So we
Yeah.
should continue
Continue.
section B. You will have OCam, so OCam will be part of it. Section B, once I think your section B is quite solid, we'll mix in some other topic. But we're already at paper territory. That's what I'm trying to say.
So I'm on track.
You're what, sorry?
I'm on track.
You're more than on track. You're more than on track. Most people didn't even reach this preparation like 1 week before O level. So yeah, so you're on track. So,
What?
I mean, most people haven't thought about how to
Illusion, yeah.
do the paper properly before prelim. We are very far from prelim. Most people think about what am I supposed to do about the paper, strategy or
Okay,
whatever.
so I screen share.
Sorry?
I share screen.
You share screen. You share screen. But more importantly, you now look at the
So that day we did until the second paper, right?
we did until the second. I'm not sure whether we finished or not though. That
Oh
one,
wait, no. But you said you wanted to cover for pollution.
pollution. Let's talk about pollution, right? So we have half an hour to talk about it. It's not very difficult. Half an hour before a new student coming. He'll be a junior lah. So this is just his extra days lah, because I need him to catch up before holiday ends. Right? Okay. Now, pollution. Now, do you have your own notes or slides or whatever regarding pollution?
No, I don't remember learning pollution.
Pollution is not very difficult. Okay, look, let's don't have to go through any concept one. There isn't much concept there.
Yeah, but you memorize, right?
True, but you need to know what to memorize. I already told you that the last question is very good. Now let's go through another pollution question so they can see for yourself. Now, in this case, share your screen, go to whatever paper, right? And then let's go find the pollution question. We go to page 100 again, right? Okay, down there. Okay, let's start looking at from here. Okay, what paper is this? This paper B? No, this is answer key. So I guess we don't care about answer key. Okay, let's go another 20 pages. Let's skip the MCQ. Should we skip the MCQ? No, maybe we shouldn't skip the MCQ. No, maybe we should. Okay, go down. Down. Pollution is around.
The pollution is in MCQ or is it in section B?
There's every topic is MCQ one, but the pollution should be before electrolysis. Okay, let's check before electrolysis. Go up. Electrolysis here. Okay, slowly. Endothermic. No, wait. It's not here anymore. Okay, not. Okay, let's go down. Okay, this is not it. It's not. Let's go down again. Let's go down. Let's go slowly after electrolysis. What is this? Stop. Be slow.
Oh, I don't see anything. This
No. Oh yeah, no.
It's all OCam.
Yeah, this one no. Okay, this one also no. Everything no. Yeah, no. Okay, never mind. Let's go to paper 2
Is
then.
it still in the syllabus? Because I actually don't remember learning it.
It should be pollution. Don't think can.
Oh, that's long-term pollution.
There you go. Okay, this is a simple one. Okay, not very common, but this is clearly asking for. So part A, plastic, right? Do you have any idea? Okay, do you have any idea?
No.
Okay, it's
but I think it's because of what we said last time. It takes long to decompose.
Yeah, that will be the essence of the answer, no matter how you put it. Good lah. Okay, so you just form a question, form an answer based on that idea. Okay.
Sorry?
You just form an answer based on that idea. The problem is plastic cannot decompose. Problem is so long term lah.
It cannot decompose, or it takes long to decompose.
Okay, more appropriately, it takes very, very long. at this point, it doesn't matter. So it's very, very long. Okay. Okay. That's the idea. You got the idea. It's just forming the sentence. Okay. Do you need me to form the sentence with you?
Right, I think I can just like say
Mm,
plastics
Mhm.
take very long to decompose.
Mhm.
Wait, but what do they mean by carelessly discarding?
Mm, I mean, I think he's admitting that plastics are made to be discarded, at least some of them. Let's
Yeah,
check.
then what is the proper way of discarding plastics?
Hmm. I mean, you can always argue the recycling route lah, but recycling plastic is very hard, loh. So however, he doesn't care about that. When he say carelessly discarding, I think it simply means that you are throwing more or using more than necessary. Okay, that means they are discarded plastic, which is, yeah, unfortunately have to be done. But again, we don't care. Carelessly discarding means it's a bad way of discarding plastic. Loh. It's a wasteful way of discarding plastic. So to me, I will answer it this way. So, since plastic take a long time to decompose or decay, decompose better. Carelessly discarding plastic, see, I'm just saying what he said. Okay, will remain wrong in the environment and causes long-term pollution. Ta-da.
Actually,
I mean, for 1 mark, I think the idea is important and the rest is just trying to answer what he wants. I mean, you can tell I'm using his phrases, which is an important way of answering. Okay.
yeah.
Let's look at the answer key later. Because for 1 mark, as long as we get the idea and we use the words that he wants to use, that's fine. Now, let's talk about B. What's the idea here?
Why you should?
Not recycling metal, right?
Yeah, so it's not recycling metals can cause
What's the issue here? Try to understand the issue. The issue is not something you memorize, you see. The issue is something you understand. For example, plastic, long time to decompose, it's something that you understand. Not recycling metal. What's the problem? I'll give you a hint.
because metal is a finite resource.
Very good. So not recycling metal. What's the problem?
May cause future generations to have a shortage.
Yeah. Ta-da. That's the idea. Ta-da. You get the idea.
No, but why is it finite?
I'm sorry? Like,
Why is it finite?
why is it finite? Because you mine it from the earth.
Oh yeah, okay, I'm stupid.
That's the reason. Now you're trying to understand that. Good question. That's why I answer. Okay. You mine it, you'll run out sooner or later.
Incomplete combustion because CO what?
Dangerous to people. And CO, you have to describe why CO is dangerous to people. Do you know?
Why is CO dangerous to people?
Yeah, you probably need to describe that just to be safe.
I have no idea. Wait.
So the incomplete combustion of carbon containing fuel will produce CO, right? CO, and CO will bind to hemoglobins. That's the minimum answer you must.
Bind to hemoglobin. How? And do what?
Hemoglobins is the thing that carries oxygen and carbon dioxide in your blood. But I think for 1 mark, just say CO will bind to hemoglobin, right? Killing people. Done. Shorter way. Okay. CO is dangerous that way. Okay, you okay with C?
Yeah.
Okay, how about D? We actually talked about D last time. It's something new to you, this aspect.
What is combustion of fossil fuel cause damage to buildings?
Correct. It's not CO2, yeah? The problem is not the CO2. The problem is not H2O. You know that's the reaction of combustion. Those two are not the problem.
Is it acid rain?
Yeah, but what causes the acid rain? It's not CO2 again. What causes the acid rain contained in the fossil fuels? We talked about this last time.
Yeah, is it sulfur dioxide or natural? I forgot.
Yeah, the sulfur content. The nitrogen dioxide is usually not this lah. Not the source is not fossil fuel, but
But where
this
does the sulfur dioxide come from?
again you ask the same question. I told you that remember fossil fuel is made mined from earth, drill well and
Oh
everything.
yeah. Okay.
Things
Yeah, I
will get
remember.
mixed in one. Things will get mixed in. And certain fossil fuel source have more sulfur, certain has less. All of them have sulfur. All of them. So the sulfur will be will kena burn also lah, right? Something like that. Become SO2 and acid rain damages building. That's the idea. The idea is fossil fuel is dirty. It contains some sulfur, for example. Okay. Let's look at the answer key. Let's see how good we are.
Wait. So to phrase the answer, like you must say like combustion of fossil fuel may lead to emission of sulfur dioxide. Then sulfur dioxide when can cause acid rain,
Yeah,
which
will damage.
can damage buildings.
Roughly, that's the idea.
Wait, the answer key below, right? Not on top.
I think so below. And yeah, I don't think there's a very pollutant question, except for example, the paper, the part 2 one. Yeah, he doesn't even talk about the source of sulfur dioxide. So you're at the right track. See, plastic are
Sulfur
not.
dioxide reduces the ability of the blood to carry oxygen.
Yeah. So binding to hemoglobin is equivalent to that phrase, no? Equivalent. So if you find this phrase better, go ahead. The rest, the idea is clear, right?
Yeah.
Now you want to get the idea, right? After a while, there isn't much. Now, shall we go to the next paper and find the pollution question, and try to do it? Yeah, let's ignore the MCQ for now, right? Now, let's go to paper 2, which is not this one, not this one. Not this one. Let's see. Not this one, not this one, not this one. No, oh, there you go, there you go, there you go.
Where? What?
Hello. For catalytic converter.
This is considered a pollution.
Catalytic converter is to, to deal with the pollution from the car exhaust, of course. Know me? Remember? That's what back then. The moment you see catalytic converter, oh, car, oh, exhaust, oh, reduce pollution, oh, react this with that,
I've done this question. This question is in the TY as well.
Then should we talk about this again or should we skip?
I don't remember. These are like way back.
Okay, you gotta understand the graph first. The graph is new, yeah. The graph is not in the syllabus. They give you in the exam lah.
Yeah.
Better understand the graph. That's the whole key. If you don't understand, let's talk about it. You understand the graph and the question?
I think so, but it's a bit complicated, but I think I understand.
Okay. Okay. Which one do you have trouble? You have done this before, huh?
Use oxidation states. I don't remember because so long ago. Use oxidation states to explain whether reaction 1 and 2 involve oxidation reduction.
Oxidation state is easy lah. Can you do it by yourself, or do we have to do it together?
I can do it.
Okay, let's forget that. So that's not pollution.
Describe and explain how the none of these is.
Yeah, these are not in the syllabus. These are in the graph. So we gotta have to understand the graph here.
No, but none of these are pollution.
This is
this is pollution. Right.
Catalytic converter is pollution.
But this, how this about pollution? Describe and explain how they're changing.
Yeah, I mean, the rich lean one is in the graph. It's in the graph. Let me put it in a simple way. It's very unlikely for this question to appear in O level. Very unlikely. Okay. Do you want to talk about it? The rich lean one, the rich lean one are very unlikely to happen. Do you want to talk about it?
Yep.
Okay, so then look at the rich and the lean. We have to understand the graph. So he tell you lean is actually he talked about the air fuel ratio. He did tell you, right? See, the lean air fuel mixture has a higher air to fuel, so less fuel lah. Lean, no. Rich means more fuel than air, maybe something like that. That makes some sense. That's lean.
But it's quite simple, right?
Oh, it is quite simple. The meaning is
you just say like when it goes from rich to lean, then the HC and the CO increase.
How when you go from rich to lean?
Yeah, as the air fuel mixture of the engine gets leaner.
Yeah.
The conversion efficiency of hydrocarbons and carbon monoxide increase.
Which is now let me test you. Does this mean that it is more pollution or less pollution?
Is less pollution is better.
Correct. As in HC conversion is higher, means less pollution from HC or more.
Yes. Then CO more CO2 come out instead of CO, which is good.
Which is good. Yeah. However, but there's a however. However, as you go to lean, the conversion efficiency of nitrogen
oxide
decreases. Yeah, which means something else Which is
bad.
I mean,
bad. It's bad.
It's bad in a different way, right? So this is bad for the building right? Bad for the building because again acid rain. Acid rain. Okay, right. If you go to rich, it's better for the building, but it's worse for the people and worse for the greenhouse gas, because hydrocarbons are also there. So you have a trade-off here.
They can go like 0.991.
Roughly, yeah. You want to choose, where things are reasonably high for both, right?
Like there's like the point where all the three intersect.
Correct. But that's not necessarily the best point. Okay, that's not true. It's just that they are both high there. We're happy.
They're both high there.
Happy lah. We're quite happy. Right? So yeah, but they don't ask you to choose lah. They don't ask you to choose, right? Okay. So the last question.
Exhaust gas from vehicles without catalytic converters cause more harm to human health than those. DYD is true. Just say there is as a higher amount of carbon monoxide being produced.
Exhausted lah. I produce, sure. Produce.
Yeah, then carbon monoxide is bad lah. Like you just say just now.
The same thing
it prevents the blood from carrying oxygen.
Yeah.
Then CO2 does CO2 have harmful effect?
Not to human being lah. More
then
towards the environment.
Like CO2 is harmless
yeah,
humans.
But relatively harmless. Sorry, relatively harmless. Relatively. It can be toxic also. Okay, so yeah, I mean, you're already seeing some repetition. That's what we expect out of the pollution chapter. Let's just look at part. What's going on here? Let's look at part 2. Part B, see whether they have another pollution question.
Part B.
Yep. Just now is page, I think 150 something or 16.
It was 197.
Oh, there you go. Yeah, nice. Almost there. Yeah, this is part B. Any pollution in part B? Is this? No, this is not pollution.
This is ammonia.
Ammonia, right? Okay. Good. All right, one pollution question per paper, except for special papers.
But is it just?
Check the answer key first. Check the answer key. There you go. There.
What? Then this? Oh yeah. Oh wait, no, this is not a question I was looking at.
I mean part B lah. Yeah, for part B.
What? How come how come the question is different?
Yellow, how come? How come it's 4 marks? Wait, that's a bit weird.
How come it's different?
Yeah, how come it feels different?
Yeah, it's
But
different.
the first one is oxidation state. That is correct. But how come B is 4 marks?
Maybe wait, just now was it 4 marks?
No, it was 2, I think. Let's check it out. A bit high up there. Oh, what is this? What is this? Wait, what is this BO thingy? Wait, stop here, stop here. But this is not, no, this is not pollution. So this doesn't feel like pollution. Sorry, go on, go on.
Wait, what? Oh, that is up here.
There you go.
Oh, it's
Oh,
4
it is
marks.
4 marks.
Oh,
Oh,
describe and
wow.
explain. I just describe only, never explain.
Oh, wow, that's why. Okay, both of us missed that. Wow, wow, wow.
Oh, but isn't it just because as you go higher, if you go higher, wait, lean, let me check.
Yeah, lean.
Lean has a higher ratio of air to fuel.
Yeah. Yes. So more air, less fuel, right? Kind of like air goes up, fuel goes down.
But then that doesn't make sense. Then shouldn't there be more nitrogen oxide?
Okay,
Oh wait,
looks like,
yeah, there should be more wait, no, that means it will convert less.
look, the conversion, look, you gotta understand catalytic converter. Just stop thinking. Listen to me for a while. The catalytic converter needs to take both CO and NOx. He takes both of them, smash them together, whatever, and then the CO becomes CO2. Okay, the NOx becomes something less, how to say, less problematic lah. Nitrogen, for example. Nitrogen is okay lah. Okay, so basically the catalytic converter kind of takes the oxygen from the nitrogen oxides and give it to CO. Simple, right? But to do that, you must imagine it this way lah. The relative amount of CO and NO must be around the same lah. Then you can convert. It's not magic, ma. Catalytic converter is just, mashing those two things together. For example, if you have too little CO, then you have nothing to mash with NO. Then there won't be much conversion, no matter what the name catalytic converter is lah. You understand me?
Mm-hmm.
You have to have relative amount. Now I'm already leading you to the answer already. It has something to do with the air and fuel ratio. Do you need more hints?
Air got oxygen.
Yes, air got oxygen. That's not the most important point. Air also have
Nitrogen.
And isn't that the source of the nitrogen oxides? The source of nitrogen oxides is not the fuel, it's the air itself.
So with more air,
you have more nitrogen oxides. With less fuel, you have less
carbon.
Therefore less CO lah. So isn't it a big wonder when you have more air and less fuel, you have more NOx, less CO, then the CO almost all gone, but the NOx will remain around there. Yeah, that's what it means. Correct. That is the basis of all the explanation, really. That is what they want you to get from here. Admittedly, this is not easy to immediately grasp lah. But
do they teach catalytic conversion? Like,
yes, it is. Oh, it is taught. But the air lean fuel mix ratio, no lah. That's new here. Still a rather difficult question. But if you don't understand catalytic converter, like I explained to you just now, I have explained very briefly. Yeah, you have to lah. You have to understand that. Okay. But this is a good, I guess, a good knowledge for you.
So like as the air to fuel ratio gets leaner,
okay,
there is more nitrogen. There is more nitrogen compared to carbon.
more nitrogen oxide produced. You can just jump to that.
More
Right.
nitrogen oxide produced compared to carbon monoxide.
And less, just say less lah, less carbon monoxide produced.
Oh,
I mean that there's no jump in logic, right? That kind of like you can kind of say that, I guess.
yeah. Then what? Hence what?
Yeah. What does the catalytic converter do?
It takes away the oxygen and gives to the carbon.
Yeah, so it takes away the oxygen from the nitrogen oxide to the carbon monoxide, basically, right? Basically, no? So again, with more NOx available and less carbon monoxide available, what will happen?
There will be a lot of nitrogen oxide left over.
Yeah, but most of the carbon monoxide will be
used up.
Will be used up or converted to CO2. That's, I guess, a nicer phrasing.
Then must you explain the other flip side also?
You have, but you already did that. There's more nitrogen oxide left over, right? Nitrogen oxide left over.
But must you explain when the thing gets richer?
I don't think so. He just won from Rich Shuli. He does want the hydrocarbon explanation, which we haven't given him. By the way, the question kindly revise the catalytic converter for you. Like, to be fair, the question even tells you that what happens in the catalytic converter, including what happened in the hydrocarbon.
But then, but why does the hydrocarbon get?
Yeah, look at the question above. The question actually kindly explains it to you, right? See, conversion of hydrocarbons into carbon dioxide and water, lah, right? Is this how does this happen?
Addition of oxygen.
Except for the fact that most of the oxygens are already used in the exhaust gas. This one you have to understand. There isn't much oxygen left over here. Do you understand why?
No.
Because this comes out from the engine. Oh dear, now you have to understand what the engine does. Very easy one. The engine takes the fuel, hydrocarbon, and burns it with oxygen. That's what the engine do. Boom, correct? What happened to the oxygen?
Become carbon dioxide and water.
Correct. It is used up. There is no oxygen in the exhaust gas. I mean, that's saying it very extreme, but it's roughly true.
How is it affected by the air to fuel ratio?
When you have more air, you have a likelihood of slightly more oxygen left over because you're burning less fuel. It is less fuel, more air. Air is the source of oxygen. Fuel is the source of, well, hydrocarbon. Oh, hydrocarbon and air is supposed to be a certain proportion, right? A certain ratio. Hey, you're giving me more air. Oh, I might have some oxygen left over. Maybe. If I have any leftover hydrocarbon, which is already unlikely, because this is already less fuel, more air. By right, there is very little hydrocarbon left from the engine. But if there is anything left over, I think there's still slightly more oxygen left. So oxygen and hydrocarbon can also react. No? But again, it is already unlikely to have any leftover hydrocarbon because it's already less fuel, more air. The exhaust,
if that is right, you'll all get.
It's very likely that most of the fuel are used up now if you're using a linear ratio. That's before the exhaust, right? Before the catalytic converter. So you already have less problem entering the catalytic converter, so to speak. Aiden, I can see you. Can you hear me?
Yeah.
All right. Then let's go to the Jamboard that we use in the afternoon. Shall we continue from there? Okay. For you, John D, are you comfortable with this question? It is a very good revision, though, I must say. It's forcing us to revise. In a very
comfortable, yes.
I'll let you try to think about the next pollution question. I mean, the next paper lah, usually. Give it a try, see how comfortable you are lah. Well, our revision is very good at this point. There isn't much lah, seriously. You just have to understand these few things. Now, all the questions are good. All the questions are good. Okay. Can I stop your screen sharing? Would that be okay? We'll do it in the Jamboard lah. So would you please do it more slowly, like you copy it to the Jamboard and try to construct your sentence. There will be a lot of English. Okay. Okay. So for Aiden, where is okay? There you go. We're still using the Aiden trial Jamboard.
Yeah.
Right. So Aiden, at this point, we're not doing a past topic. I'm just trying to get you to have a feel of the mole topic a little bit, right? Because I want to have a feel about your chemistry. For example, just now I feel that your term 2 is actually not so bad, right? Besides acid and base, besides acid, right? So I'm going to continue with a little bit more, right? A little bit more. Okay. But first of all, let me put you on this. This minute. Okay, so Aiden, we are at the point of I was comparing your answer with Joshua's answer, right? I was telling you that depending on the situation, your answer may be correct or his answer may be correct, right?
Yeah.
Do you still remember my explanation?
Yes.
Okay. Now, if you're being very strict, this is 6 molecules only, and this is 3 molecules only. Then whose answer is correct?
Then the other guy's answer is correct.
Correct, because we cannot have half a molecule. That's the reason why. However, chemistry is not interested. Sorry. I cannot say that. Chemistry is interested in molecule situation, but also in a lot of molecule situation. So this is very few molecule, but also a lot of molecule. So for example, let me give you an example. So for example, we now have 6 million molecules. Let's pretend that for now. 6 million molecules and 3 million molecules. Okay. Now, whose answer will be correct? Is it still Joshua's answer?
I think it's still his answer.
Yeah, which answer? Sorry, which answer?
Still the other guy's answer.
Oh, no. It's your answer. It's your answer. Let me show you why. Your answer is now 3 million lah. 3 million molecule and 3 over 2 million, which makes a lot of sense. 3 over 2 is 1.5 million. Can what?
Yeah, so it's not a fraction anymore, then it works.
Correct. Simple, right? Simple. And chemistry is interested in both situations, both extreme. The one with very little molecule, very few molecule, and the one with stupendously lot molecule. Now, I'm explaining this to you at the start because you see, sometimes fraction we have to care. Sometimes we cannot accept fraction. Why? That's the situation of very few molecule, which is the balancing situation. No? You understand?
Yeah.
But in other questions, especially after balancing, we no longer care about very few. We care about so many molecules such that fraction becomes acceptable. I am explaining this so that you're not confused. How come sometimes fraction not acceptable? Sometimes fraction is. Depends on the situation, no?
Yeah.
Okay, yeah. Can, yeah? This is the start of the mole chapter. Okay?
Yes.
Okay. So the balancing is clearly very few molecules. Now I will now show you all the other scenario, which is stupendously many molecules. Right? At that point, fraction is allowed. Very ugly number is also allowed. Let me show you what it means. Now I can duplicate, but I don't want to duplicate. Okay, go to the next page, please. Now, John D, are you pasting any question on the page 10?
I'm doing it. Yeah, I can do that.
Okay, let me follow your working, at least for the first few questions. Let me follow. So Aiden, let me show you, ugly numbers. Let me give you ugly numbers. For example, page 5. Yeah? So 1/3, reasonably ugly, right? 1/3 trillion molecule. Let's pretend for it. So I'll just put 1. Is this fraction acceptable or not?
It's not.
It is, because 1/3 trillion. I know that actually means, wait, that means one of the molecule cannot be divided by 3. What?
Yeah, that's why it's not.
That's mathematical, I know, but in real life, yeah, very roughly, that's okay lah. We don't, because we cannot even measure exactly 1/3. It's maybe 1/3 plus and minus, so we consider it can low, acceptable low, so many molecule whatever lah. Can you accept that kind of logic?
That kind of logic, yeah.
Okay, so 1/3 trillion acceptable, 1/3 molecule not acceptable. That's simple. Can you?
Yeah.
Okay. So here's my question. If this is acceptable, how many molecules do I need so that everything will, react lah? How many molecules here do I need?
What do you mean by how many molecules?
Let me give you an example. I need 1/6 trillion H2SO4. That would be a nice thing. Remember, 1 molecule, 2 molecule. Hey, this is what it means lah. 1/3 trillion here, 1/6 trillion here. No? How do I know? Very simple. This is 1/3 times half. Do you understand what I'm saying here? If you don't, let me explain.
Because you're trying to get half of 1/3.
Correct. Because that's what the balance equation told me. For every 2 molecule, I need 1 molecule. Half low. Do you understand?
Yes.
Okay. Now, what will I get as the result? Give me the number.
You get 1/6 Na2SO4.
Yep.
2/3.
1/3. 1/3.
Yeah, 1/3.
2/6 lah. 2/6 lah, if you like. 2/6. Okay. You got it? You got it? That's the concept. That is the mole ratio concept. Okay.
Yeah.
Okay, good. Not very complicated in terms of math, I hope. And chemistry-wise, I hope also not very complicated. Let me test you one more time with some ugly number, okay? Some ugly number. Now, if I want 5.93, super ugly, right? 5.93 million. If I want this, how much do I need here?
You need 5.93 of H2SO4.
Correct.
And 11.86 NaOH.
Now, let's say I don't care about 11.86. I just say it's 5.93 times 2. That's the concept. Of course, it is 11.86. You're correct.
Yeah.
Okay, so that's the concept. And like it or not, I will get, I will get something else also. What will I get?
11.86 million of.
Correct. Of that guy lah. Yeah. Like it or not, I will always get this. There is no way to avoid it. That's the chemistry. That's the chemistry.
Yeah.
You understand the chemistry and you understand the math?
Yes.
Good. Now let me show you the full extent of the mole. John T, I'm not seeing any questions. Are you okay? Are you sure?
Go to page 11.
Oh, page 11. Okay, sure.
I need help with the part 3.
Okay, just a minute. Yeah, just a minute. Now, Aiden, give your. Oh, sorry. Let me give Aiden the questions. Aiden, I'm giving you the numbers which are slightly harder to work with, right? From the first reaction, I'm putting it in page 6. Now you are gonna create your own question. Very simple lah. Just give yourself one of them a random ugly number, right? So do that in page 6, right? Okay. Which one do you want to start the question with. You're making your own question. First guy, second guy, third guy, fourth guy.
First guy can be C3H6.
Oh, no. Okay, let's stick with that's the second guy because you know at page 6 is already like that. Okay, you see page 6. Okay, right. So give yourself a starting number. First guy, second guy, third guy, or fourth guy. Where should we start with?
The second guy can start with like
Okay, what is it? How many?
5.98.
Okay, 5.9. Okay. Now do something more different. Okay, for example, 9.53. Okay. Then put this, I don't know, 1,000. Okay. So what happens with the rest? You work it out. Okay, Jonty, what's your problem? Question part 3, is it? Why is it possible? Oh, both car engine.
How do I explain in words? Oh. Yeah, I don't know how it's formed in fuel cell.
Let me think forward. Yeah, both car engine and engine powered by hydrogen fuel, sure. Or a conventional petrol engine. Now, of course, the petrol engine one is the basically it's just the nitrogen reacting with the oxygen, both found in the air under high temperature.
Yeah,
the
flame,
engine, very
combustion.
high temperature. Yeah, very high temperature, that's possible. Let's see. Oh, hydrogen fuel cell. Oh, right. So let me give you a hint, right? So the other way for nitrogen oxide to be produced is naturally. So it's not because of human. Okay, naturally from lightning. What does lightning do? Lightning zaps the air lah, correct?
But that's not indoor. That is not indoor. That's not in the car engine.
Yeah, I know. I'm not telling you the normal car engine. I'm not saying there's a lightning in normal car engine. I am giving you a hint that come on, the hydrogen fuel cell produces heat, electricity, right? Fuel cell is supposed to produce electricity.
Yeah, but
I'm not saying that that's a very. I'm not saying that that's a very. I'm not saying that that's a very high voltage. I guess I'm not saying that, but it is a lot of electricity compared to a normal car engine. And I know it's not as strong as the lightning, but you know, lightning produces nitrogen oxide from simply combining the nitrogen and the oxygen in the air. So a fuel cell, which is supposed to be very clean, still gives off electricity, which may produce small amounts of nitrogen oxide. That is my guess, by the way. I don't know the answer here. That's my guess. I might be wrong.
But that sounds very like anyhow one.
I know. But that's my guess. I mean, it's not in the syllabus. I have to use my previous knowledge to guess. That's the idea, Jonty. That's the idea. You're not supposed to know it. You're supposed to guess it based on previous knowledge. So guess you do. That is what some of the questions are asking you to do. Now, I'm telling you this because this is not in the syllabus. If it is in the syllabus, I'm telling you.
Heat that it produces.
You think the heat of a battery, hydrogen fuel cell is a battery, basically. You think the heat of that is higher than the heat of a combustible petrol engine? Cannot be, right?
No, but then the reaction is exothermic.
You're correct, though. No, you're correct. It is airway. Oh, it is exothermic. You can also argue that because you know what? I cannot say you're wrong. You are relying on previous knowledge also. You might be right. Okay. So let's write our preferred answer based on our guesses, and then let's look at the answer key. Really, that's what we need to do.
You don't write your one or my one?
No, that's up to you.
Oh.
You have to decide because this one is not in the syllabus, right? So Aiden, your ratio is wonderful. What is this ratio? I cannot see it. Somehow it's being blocked. Wait.
It's blocked.
Yeah, it's blocked on my side, not your fault. Wait. Sometimes this happens to Jamboard. Wait. Oh, okay, I can see it's 9/2, right? So I agree with your ratio. It's 9/2. The math is quite simple, yes?
Yeah.
Now, can you handle, for example, no, I like your attitude, you don't really care what the real number is after this. I mean, in the sense, you are right. As long as you get the ratio correct, it will be correct one. Who cares what is 6/2 times that? That will be correct. Something like that. Okay, so, just to close off the thing. So let's say this is 1,000. What will be the rest be?
If that is 1,000, then that will be 1,000 divided by 9 times 2, which is 1,000 times 2 or 9.
Yeah, something like that. Right. So that's the ratio. And then the next one.
Next one is 6/9 times 1.
Yeah. There you go. Yeah, done. Okay. So at least your basic math is strong. So I'm happy. Okay. You got it, huh? This is how you deal with this is what you call the mole ratio. The mole ratio is a very important concept you're currently getting. Okay. Any questions so far?
No.
Okay. Again, Jonty, when you're ready with your educated guess, check the answer key. Now, Aiden, the next part is, let me tell you, right? They never give you how many molecules. Remember, this is 1,000 molecules, million molecules, trillion molecules. They never. They give you all sorts of other things which are more natural. Let me explain what it means. Oxygen is gas. Yes, oxygen is gas.
Yes.
Now, you have three options. Let's say in the lab, you have, mass law, the mass of a gas. I mean, clearly gas have mass, gram, kilogram. Is that really natural to, I want you to use 1 kilogram of oxygen. Does that seem natural in a lab setting?
Not natural.
No, I would agree with you. What's more natural? Gas, you will quote in what kind of, amount?
dm cubed. You cannot measure this.
Correct. No, you can. Actually, you can measure the mass of gas. It's just very annoying. But measuring the volume of a gas is much easier, much more natural. So yes, you are right. You will quote the gas in volume. Can? Make sense? The volume is usually dm cube, or a smaller volume will be cm cube. Okay. Here lies the practicality and here lies the problem, because dm cube and cm cube are not molecules. You have to find a way to convert the volume into molecules. That is your need. Understand?
Yeah.
Now, C3H6, I'll tell you straightforward. It's actually liquid. You don't know this, I'll just tell you liquid. Now, what's a natural way to measure liquid?
Just put inside a beaker.
Correct. Which is to say volume You must be saying
Yeah.
So again, same thing, I never quote to you, hey, yo, Aiden, you're gonna put in 1 million molecule of C3H6. How do I measure that? I cannot pick up the molecule one by one and measure. You are right. You can only measure the volume. So the practicality comes in and the problem stays the same. How do I convert volume to molecule? Because you must understand, this is 1,000, this is 2/9, 1,000, This doesn't work when you put in volume. It does not. It only works when you put in molecule. Frankly speaking, because every molecule has different volume, you cannot compare it that way. The comparison only works with molecules. You're saying?
You can find the amount of molecule per unit volume.
Correct. You need that. And that is what the chapter will teach you. Make sense?
Oh, okay.
You need that. I'll show you later. Okay. I'll briefly describe the problem first. Right. Before that, Jonty, have you checked the answer key? How is it?
The answer is like 1 line only. It just says that nitrogen and oxygen react to form nitric oxide at high temperatures. Then both engines operate at high temperatures.
Oh, so your guess is correct now?
Yeah, but I wrote it in 5,000 lines, then they did it 1.
Hey, First thing first, you're correct. Be happy first lah. Why so pessimistic? You're very fast in your answering anyway. Okay.
So I continue doing position question.
Do another one until you say that you're comfortable lah. It has been bothering you, right? I mean at most 2 more questions lah. To be serious, at most 2 more. It's enough. Okay. Then you can go to exam and do it already. Can just do 2 more lah, maximum. Now, Aiden, how about something which is naturally in kilogram? Let me show you lah. So there are certain things which are more natural in kilogram. What are they? Well, obviously solids. Now, tell me something which is naturally in solid.
My computer.
I know, but in terms of chemistry, something simpler than a computer. Something solid in the lab.
Like silver powder.
Okay, silver powder. So Ag metal will be solid. Sodium metal will be solid. Actually, the insoluble things, the insoluble salt that you memorize, remember from the previous chapter, they will also be in solid. Those kind of things, especially powdery stuff, will be measured in gram or kilogram. It's natural. Can you accept that gram does not work at all for the mole ratio? That's wrong.
Why does gram not work?
That's a very popular question. It's very simple. Because everybody's density is different. For example, Ag density is very dense. How do I know? The MR of Ag is very high. It's like 190 something. I don't know. I forget. 100 something. 190 something maybe. Depends on MR. But look at the MR of, for example, a very light thing, for example, a sodium metal. You know how not dense a sodium metal? The MR is only 23, I think. Yeah, 23. So 1 kilogram of Ag compared to 1 kilogram of sodium. Which one has more molecule? Which one has less molecule? Or are they both the same? You think first?
Ag has more molecules.
Wrong. Ag has less. Na has more. Because each molecule of Na only quote unquote weigh 23. Each molecule is light, so to speak. Each molecule of Ag is heavy, 190 is still 1:1. So 1 kg of sodium will contain more molecule than 1 kilogram of Ag.
So MR just means the molecular mass of one molecule.
Please. Yes, I can say that for now. That's a very rough approximation. Yes, that does make sense if you put it that way.
Oh.
So one molecule is heavier, one molecule is lighter, then obviously 1 kg is not 1 kg in terms of molecular. So gram and kg doesn't directly work. That is the concept. But they will give you gram and kg. Why? Natural. Just natural. Not trying to make your life difficult. That's not what it is. Ken, so far so good. You understand me? Not okay, just say it. Are you okay?
Yeah, so far I think it's okay.
Right. So gas we cover, liquid we cover, solid we cover. In chemistry, there's one more state.
Aqueous.
Good, aqueous. Now, what is the natural aqueous thing in lab? There's quite a lot.
Sodium hydroxide.
Okay, sodium hydroxide. It can be solid, it can be aqueous. Okay.
Yeah.
Let me give you something which will not be in solid. I'm just ignoring sodium chloride for, just for to not very confusing for now. Acid is never going to be in solid in lab. Never. Too dangerous, too highly concentrated. So an acid will be in aqueous state. Now, what's the natural way, to measure an acid? Like take how many acid? How do we say that?
Is it concentration?
First of all, you have to specify how strong the acid is. In your lab, you will have different concentration of acid, correct?
Yeah.
One is more concentrated, one is more diluted. Is that all you need for acid?
You need to find like cm cube of acid.
Volume. Correct. How many of the strong acid? How many of the diluted acid? Therefore, naturally in the question will give you these two, and these two will be used to find the molecule. Again, they don't work directly. Same problem one. None of these work directly. You have to convert them into molecules. That will be the next part of mole chapter. Do you understand?
Yeah, but just now you said that all of them like don't work in it. So like what works?
Oh, again, only molecule works. Only molecule works.
The molecular mass works.
No, not molecular mass. If you manage to convert all of them, into molecule, then it'll work. Only when you manage to do that.
Also, it's possible to convert cm cube
Everything. Oh, everything is possible. Not just possible, you have to. That's the point of the chapter. That's what they're trying to teach you.
Oh.
Okay, let me show you in page 7. Before that, John T, do you have the next question? Haven't, right?
Have, but it's a short, really one part.
If you're not happy with it, go find a longer one.
Yeah.
So Aiden, remember?
Tuition questions not very common.
No, that's wrong. Every paper 2 will have 1. I mean, that's what your experience one. They will have 1.
Yeah.
Cannot be. Check again. If you cannot, let me help you find. Maybe there isn't. Maybe we miss. Don't know, right? Now, Aiden, for chemistry, we don't discuss liquid. There is a very simple reason, because there are only 2 naturally occurring liquid. It's very rare to have liquid in the lab. Okay, one is Br2. Br2 is both liquid and gas, by the way, both. Another one is mercury, also in liquid, and we no longer use mercury in lab because it's very toxic. So we don't talk about liquid all the time. Most of the time, we just focus on the remaining 3. So for now, we don't discuss liquid. The rest are quite common. Again,
okay.
Gas, solid, and then equals. So remember, the natural way to present gas is
dm cube and cm cube.
So dm cube. The natural way to present solid is?
Solid is kg and grams.
Yeah.
Just kg.
Now, gram is better because usually we don't deal with a lot in lab. So it's actually more of kg. Then for aqueous?
Concentration and volume.
It must be both together. Remember, you cannot be just one. Right? Plus, yes.
Can't I also find like the mass of the aqueous solution?
Yes, but who say that? Like for example, no, you can. You can. The same thing as can I tell you to get sodium metal how many volume? Can what?
Yeah.
But who does that? Not that you cannot, but who does that? Let me give you an example. Acid. So your teacher asks you to do this. Okay, you're gonna get the concentrated HCl 1 gram. Is that making your life easier or harder?
Oh, because you can't measure 1 gram properly.
No, you can. You can use the weighing machine, and the problem is the HCl is in a liquid form. It's much more natural to measure in volume than in mass. But nothing stops you from measuring in mass. You can. It's just that it's not the most natural way. Yes, John T.
I remember on this conversation, I forgot how the water in, water out works.
Which one? Which topic are we talking about?
No, it's like the thing in the lab. Like it's used to condense water.
Yeah, the condenser.
Yeah, I don't know how it works. I forgot how it works.
You want me to explain that?
Later at the end of class.
Can. After this, yeah. I'll take the break. I understand. You want me to explain how it works? Can, no problem. Please, I will do that for you. Back to you, Aiden. Nothing stops the question from giving you, acid in gram. But to be fair, that's making our life harder, not easier. To be fair. So the question is really trying to make your life hard.
But wouldn't it be harder to measure concentration than mass?
Okay. Usually in lab, the concentration is labeled what? So the concentration doesn't say strong, but the question say something like this. 1 mole, 0.1 mole per dm cube. They already say what? They already say, and you just have to measure how many volume. Okay, so for example, your teacher will say, okay, go take the 0.1 mole per dm cube, which is very strong, by the way, and then take how many? You naturally ask your teacher, take how many? Or take 50 centimeter cube. Yeah. Then you can do it in lab rather naturally, right? You just, grab your, measuring beaker and then grab another one, slowly pour it because it's a very strong acid under the fume hood, measure 50 centimeter. Done? Right? Rather than telling you, okay, go and measure 50 grams. You can, but that's not helping you very much. It's slightly harder. Nothing wrong with that, though. Nothing wrong. To be fair, yes, nothing wrong with it. Okay. Okay, so the natural way now, everything will have a conversion to molar, right? So let me show you. It may not make sense at start, but the purpose is clear. I need to convert. That's the purpose. Now, gas is the funnest. It doesn't care. It doesn't matter what gas. It does not matter what gas. All gases in room temperature and pressure, right? 24 dm cube of any gas is always 1 mole. I'll explain to you what 1 mole means later, right? 1 mole is not 1 molecule. That's wrong. 1 mole is many molecules. How many? 6.02 times 10 to the power 23 molecules. Why this fancy number? The history is there, but let me guarantee you, this is the number that makes our life easier. And this is the unit that makes our life easier. We will not be using molecules. We'll be using many molecules called 1 mole. It's just a shorthand for many molecules. Okay. How do you convert gas volume to mole? Extremely simple. So let's say I have 2 dm cube. How many mole?
2 dm cube, then you have 0.
2 over 24. Better say in fraction.
Yeah,
2 over 24. That's it. Then you have the mole ready to use already. Okay, what is a mole? Many molecules. That one. Okay. So let's talk about the solid one. Just slightly harder. You need the MR, which means you need to know what is it. That's all right? Once you know what is it, you know the MR. Okay. So the mole will be gotten from the gram over the MR. Finish that. For example, 2 grams of Ag is how many mole over the MR of Ag? If I'm mistaken, 190. There you go. That's the mole of Ag. That. What is 1 mole? Many molecule. Again, that's it lah. It's okay, it's okay. Not that difficult, right? Just know what is it. Therefore, you know the MR. Therefore, you can convert.
So all of this is just to find the mole. The
mole, which is, then we can apply the mole ratio, and then we can do all sorts of things. Okay, not very complicated. Do you have to memorize the formula? Well, yes, you do. Yes, correct. You have to lah. You have to. But know the purpose. Jonty, are you okay? Because
I need help with this question. I don't know.
Okay, right.
As an organic chem, so.
Oh yeah, PTFE is new. Yes, okay. Let's talk about it. Please do something else first. Let me just finish Aiden, and then I'll get back to. Okay, please. Okay. Remember, don't wait for me, Jonty. Skip to the next question. Do something else. Collect your questions. Right. Aiden, the concentration and volume turns out to be actually rather easy, rather easy, because the concentration unit is already very helpful. Look at that. Okay, 0.1 mole per dm cube. Let's say the volume is 50 centimeter cube. Now, isn't it a simple matter? 0.1 mole per dm cube, which is the concentration, times
0.05 dm cube, which is 50 centimeter cube. Correct? What happened? You have the mole.
Why is it multiplied by 0.05?
The question is not the number. The question is the unit. Don't you see? The unit is the y. The concentration is mole for every dm cube, right? That's concentration. That's the unit.
Oh, so you just want mole. You don't want mole per dm cube.
That's the unit for concentration. In this case, 0.1 mole per dm cube. So I have 0.1 many molecule per dm cube of whatever the substance. That's the concentration.
Okay.
Then I have the volume itself, because remember, that's what we do, right? When we take aqueous. Or I have a 50 centimeter cube. 50 centimeter cube is 0.05 dm cube. I mean, isn't it obvious? Mole over dm cube times dm cube / you get mole. Isn't that obvious?
Yeah.
Just from the unit, it's very simple to know what to do.
Okay.
These three ways are different from each other. Yes, I know. You have to memorize 3 of them. Yes, I know. I will argue they're not very complicated. It is important because they are essential. You cannot do it wrong. You have to do it all correct. So it's good that it's not very complicated. So far, so good. Eden?
I'm just a bit confused about the aqueous part.
Of course, but let's see it in action. Of course, this first time. You can follow until this part already good enough, right? Now let me get a question for you. No, let's still stick to the question before, right? Which is not easy because no, it's easy. It's easy. We'll do that. We'll do so. We'll use this one. Okay, go to page 8. Okay, so just to make it clear, this is now gas. So you did ask me, the state symbol important or not? Yes, it is important. Of course, it is important. You are correct. It is important. This is liquid. This is gas, and this is in this case, this will be considered a liquid. Okay, so now I want 3 dm cube of CO2. How many oxygen in dm cube, right? Do I need? That's the question.
I'm the MR, right?
Look at the gas. Look at page 8. For gas, how do we convert? Do we need the MR or not?
For gas is easy.
Correct. So don't need MR. Don't need MR. So John P, back to you. Oh, it's a bit slow. Okay, I'll make it a bit bigger. Yeah. The problem is the PTFE one, right?
Yeah.
Okay. Do you have the full question? Wait, let me think.
I have the full question, but these are the only 2 that are important. I'm trying to answer the pollution question.
Okay, caused by getting rid of the substance made of PTFE. Now here's the thing. Do they, because PTFE is new, you don't know PTFE is like quote unquote outside the syllabus. Did they tell you any other information about PTFE? Because by right, that's what they're supposed to do.
I can check. I need to go back to the question.
Yeah, you have to go back to the question and give it to me, because I can only answer based on it. I cannot answer based on my understanding.
It says that compound A is PTFE.
Really? This is the only question. This is the only thing they tell you. Does it decolorize? Effect on blue litmus paper? Really?
I'm pretty sure it's all the information, but it's not all the questions.
I mean, is there any other part of the question that
I'm trying to find it right now. Give me
Yeah,
a second.
okay. If not, then I answer based on my knowledge, which is not what the question wants. That's not how the question works.
So PTFE is not taught.
No, PTFE is not part of the syllabus. No. We can understand it, but it's not part of the syllabus. So
But I
it's
see
kind
that
of
is the polymer of compound A.
I know, but this format is almost never mentioned in syllabus. Meaning to say the question maker has an obligation to tell you enough.
Okay, so that's all the information, but there's other questions. You want me to
No, just paste the full question to me, please. Just paste the full question. If this is the full question, then that's it lah. Then I'll work with it.
these are like the only that's it, I guess.
Again, Aiden, hoping that this is how you work. So in terms of mole, right? In terms of mole, Ken? In terms of mole.
9 mole.
Like this was. From 3, you already converted to 3 over 24, which is 1 over 8 mole. I like that a lot. This is correct. I don't know why you erase it. You're correct. Ken? That's our first step. So far, so good?
Yeah.
Why do we do this? Because this is the only time, this is the only place where this 9266 works. So you have to now go to here. So the 1 over 8 will now become 6 over 9 times 1 over 8 mole. Okay? Is this correct?
Yeah.
Wrong. This is supposed to be 9 over 6. Hey, you are. I was bluffing you.
Oh.
6 over 9 or 9 over 6? Come on.
9 over 6.
Because this is supposed to be more, supposed to be less, ma? Yeah, so don't gonna bluff me, right? Okay, 9 over 6. Okay?
Yeah.
After that, he also want it in dm cube because that's just a natural thing, ma. So we have to go from mole to dm cube. No? What do? We times 24 again. No?
Oh, so the number at the top, it's in dm cube.
No, this is not in dm cube. These are all in molecules. Always like that one. Always in molecules. 9 molecule of oxygen, 2 molecule of this. But the question will give you dm cube and ask you in dm cube also because that's natural.
Then how did 3 over 24 thing come about? That's why I erased it just now because
3 over 24 is the conversion from dm cube to mole. Right? Remember, the conversion is any gas 24 dm cube is 1 mole. So 3 dm cube is 1 over 8 mole. Done of CO2. Correct or not?
that's why I thought that then on top shouldn't it be dm cube?
Which top are we talking about here?
Like this one.
Right, write something in the Jamboard. Communicate with me. Come on.
I'm lasering the thing.
Oh, you want to write it as 1 over 8? No problem. I mean, putting it here is fine. Putting it here is also fine. Do you have to put it here? I mean, this number stay 9 molecules, 2 molecules, 6 molecules, 6 molecules, no matter what you do. It stays correct. What?
Yeah, I mean,
what?
How is molecules like related to dm cube?
One more time, it's not molecule, it's mole. This is the hard part. Mole is not molecule. Mole is many molecules. I mean, so many, in fact. 10 times is to the power of 23. Remember, mole is not molecule. Mole is many molecules. Okay? Many molecules. Why do I say many? Because the fraction is valid. If it is not many, it's not valid. Okay?
Okay.
When it's single molecule like this, you cannot have a fraction. When you have many molecules, a fraction is fine. How does dm cube relate to many molecules in this case? They only tell you in terms of formula. If you want explanation to be very fair, you go to physics. That's what the syllabus tells you. I'm not going to explain to you.
I mean, the number on the top 3. Like when you write 3 CO2, does it mean like 3 dm cube of CO2?
Like this is 3 dm cube of CO2, right?
Yeah.
So I want 3 dm cube of CO2. How many do I need? Yeah, this is 3. Don't put 3 here. This 9266 is what we work out to be correct. You cannot change this number. It is always 9 molecule with 2 molecule becomes 6 molecule and 6 molecule.
Then should it be like 6/24? Because it's 6 dm cube.
Uh-oh, you're very confused. I'm serious, you're very confused right now. You're very confused. This is not dm cube. This is molecules. This is molecules. It's not dm cube. This is molecules and this is molecule. This one gets straight first. We discussed this long ago before we talk about the dm cube. You got to get this right first.
Okay.
Now let me change this to 3. And can I do that? Can I change 6 to 3? Your problem is I have to change 2 to 1. I have to change 9 to 9/2. Can or not?
Mathematically can.
Yeah, I know. But in reality, is there 9/2 molecules? Reality lah.
Reality, no.
Correct. So you don't get to change it to 3. To be fair, you can change it to 60 lah. I guess that's fine. 60, 60, 20, 90. But what's the advantage?
No advantage.
Change lower. Yeah, change lower cannot. Change higher, and I don't know why bother. I mean, you can lah, but why bother lah? Why bother? You can though if you want.
Yeah. So
Okay.
on top is molecule, but below this one is
It's not even molecule. It's first of all dm cube. No, there's no number here. There's no number here. There's no number here. This one is the number that was what we are working. The real number is 9266. There is no number there. The
Then
number is 9266.
and why is here dm cube though?
Because that's what the question now asks. It doesn't have anything to do with this. The question gives you this nice reaction, and then the question tells you, hey, I want 3 dm cube. Let me put it this way lah. Let me put it this way. Hey, I want 10 dm cube. Can? To get rid of the confusion. I want 10. It's not 6, it's not 3, it's not 1, it's 10. Okay?
Okay.
So what do you do with it? That's the question. No? Again, the question gives you the reaction and the question gives you this. So what do you do?
This one changes to 10.
All right, change it to 10, right? Okay, then you have therefore something else, which is like 5/12, I think. 5/12, right? Okay, then continue lah. Continue. What do you do with 5/12?
It turns into
You
12.
do it first, huh? You do it first, huh? Okay, John D, sorry. Right, so let me read the PDF.
Well, there's actually not a lot of pollution questions there. Like, can you check? Maybe I'm missing.
I think I need to. Yeah, because if you cannot identify that,
But there's
yeah,
actually, I don't know, but like I actually can't find.
I will help you. Let me settle the PDF first, yeah. Ah, yeah. Nice. Okay, right. Okay, nice. Okay, good. Yeah, I'm reading it.
Wait, but how does the other questions help you?
I'm not sure, but I have to know as much PTFE as possible from the question maker. I probably cannot answer from my own knowledge. Do you understand? That's what you need to do. That's what I need to do.
But other questions don't provide anything.
If they don't provide anything, that means it's already in the syllabus. If they provide something, that means it's not in the syllabus. Do you know the syllabus enough to know? Maybe not yet. That's your problem. I keep telling you. That's why I keep telling you. This one not in the syllabus. Then your response is different. If this is in the syllabus, oh, I better learn right now. You know, the pollution question, usually most of the information are in the syllabus. They won't tell you. You're expected to know. That's your response. Oh goodness, I don't know. I better learn. Hey, I tell you PTFE is not in the syllabus. What's your response? Oh, I better learn. No, wrong. I better read. Wrong response. Do you understand what I'm saying here? Okay, don't panic and do the wrong thing. You are correct to ask, is this in the syllabus or not? If that's what you're thinking, you're correct, because the response is different in exam. Okay. Okay, so now again, I think PTFE is not in the syllabus. Yeah, I might be wrong, you know, I'm not God, okay? I might be wrong, but I'm gonna go with that for now. Yep, nice. Okay, yeah. I'm reading, and that's why I'm reading, because I think it's not in the syllabus.
But it's just talking about like the
Oh, okay. Now, to be fair, after I read everything, I am now certain that they don't tell me a lot of anything new. You are right. Now I agree with you. I still think that PTFE is not in the syllabus. So
Yeah,
now
but
what do I
PTFE
do?
it's just a what's it called, alkene, what?
Now, let's say I agree with you, right? I agree
Yeah.
with you. Now, so therefore, you and I should be now thinking from which part of the syllabus can I answer this question?
Organic chem.
Okay, I already have an idea. I already have an idea. Because I've already confirmed, oh yeah, it's not from his reading. It's not from reading he gave me. It's from the syllabus. Okay, this is, however, very obvious to me, therefore, very obvious the answer. Hey, what?
But is C2F4, like, does it behave the same as an alkene? Yes, right?
The double bond, yes. The double bond, yes. Pretty sure.
Then isn't it, then are they just not talking about the pollution caused by getting rid of alkenes?
First of all, are you sure PTFE is C2F4? I think you have a mistake. PTFE is not C2F4. Okay, that's wrong.
Wait, what?
Oh dear. Okay, let me just tell you I think there's a misunderstanding here. PTFE is the polymer of C2F4. Hello.
Uh-huh.
It's not the individual C2F4.
Okay.
You're dealing with chains of C2F4, which is very different from dealing with C2F4. C2F4 is an alkene. The chain is no longer an alkene. Hello, you're wrong. Do you understand? You're not dealing with alkene. The double bond is already gone in the polymer. You open it, ma?
Uh-huh.
You're dealing with PTFE, not with alkene. Wrong understanding. Wrong. You're dealing with polymers. Do you get it or not? Do you get it? Do you get it? Okay. Then you have to think in terms of, PTFE is a polymer, right? And they keep asking me to draw. So at least I have an idea what kind of polymer. So I get an answer from that point of view, right? I get an answer from that point of view. You understand it? Okay.
Awesome.
Now, Aiden, back to you. So Aiden, the 5/12 or 10/24, is it okay so far? That's the mole of CO2.
Yeah.
Okay. Going to here, how many mole of O2 will you be needing?
12/5 times 9.
5/12, is it? So because I keep explaining. 5 over what? 5 over
12/5.
12/5 times 9.
Yeah.
Why is it 12/5? Huh?
Because that number has to be bigger than that number.
Uh-oh. Now, I'll give you the correct answer first. The correct answer looks like this. So 9/6, using, the 9 and 6 ratio, right? Times the original, which is 5/12. That will be the answer, first thing first. Now, let me give you an example of why this is correct. You have to understand why this is correct, not just, teacher say, okay, no, that's not. Now, I'll give you this 1,000 molecules of CO2, easy number to work with, 1,000 molecules of CO2. So how many oxygen molecule do I need?
I need 1,500.
Yeah, but say it as 9/6 times 1,000, correct? That's why you get 1,500. 9/6 times 1,000.
Yeah.
So if I have now an ugly number, don't let your math get messed up. I have 5/12 molecule of CO2. What is this, man? Well, I don't care. How many molecule of O2? Well, 9/6 times 5/12. Does it?
Oh.
Okay. Don't let the ugly number mess you up. That's my message to you. The logic must still be strong. If you can deal with 1,000, you should be able to deal with an ugly number. That's important. This is psychological. This is not even chemistry or math. This is psychological. Ugly number makes us do weird things. Don't. Take with the logic.
Oh.
You understand what I'm saying? That's my message to you. That's most people's problem at the start.
I see.
Okay, Ken, yeah? Ugly number or nice number, same logic. Stay strong. Ken?
Yeah, can.
Now I have the mole of oxygen. Good news. I'm already one step from the dm cube of oxygen. No? I still have to do that. Do you have any idea how to convert it to dm?
You mean convert 9/6 times 5/12 dm cube?
No, that's a mole. 9/6 times 5/12 is a mole, correct? That's a mole. How do I convert it to dm cube? Ding dong, ding dong, this thing. How do I convert it?
1/24.
No, wrong. Times 24. No, wait. Use your math logic again. Use your math logic again. Okay, math logic. So math logic has to be strong when numbers are ugly. This 9/6 times 5/12 is here. 9/6 times 5/12 mole, right? Math logic. Math logic. Okay.
Yeah. Oh, that's why it's times 24.
Yes, math logic and nothing else. Be strong when the number is ugly. Be careful. Times 34. Okay. Yeah. Okay. The ugly number is a feature in chemistry. It does wonder to our thinking, as in a bad way. In a bad way. You handle it properly, the bad numbers, you'll be strong. Yeah, you'll be fine.
Yeah.
Okay. Are you clear? This is your first mole question, something like that.
I think that I may not be completely clear, but at least now I have like a insight as to like how mole is like.
Correct. And that's what I want to achieve. Especially with the future topics, I want to achieve insights, not complete understanding.
Yeah,
Do you know why?
Because complete understanding is built up over time.
Very good. By listening to the class, hopefully the class now makes more sense, right? Hopefully lah. Because you have insight already, man. Some sort of insight lah. I give you the essentials, right? I skip through a lot of things. I only give you the essentials. How do you know? No, you don't know. You just believe me. You see for yourself later in class, you understand or not. Am I telling you the important things or am I telling you the stupid things? Right? You have to see in class. So you have to pay attention in class. But you will be able to understand more lah by right lah if I'm not, bluffing you. Correct or not?
Yeah.
How do you know? Later, not now. Now you're just, casting me a bit. What it also means is that you'll be able to do the practice questions from your teacher faster. And therefore, you can do the exam level questions faster, which is, of course, good.
Yeah.
So that's why we do a future topic. It's a different goal from doing the past topic, totally different.
Yeah.
Okay. For today, this 1.5 hour, you're in. Wait, is it 1.5 hour? Wait, sorry. When did you start? Sorry, I might be wrong.
I'm not sure. I started at.
No, you started at 8:30. Sorry, it's not 1.5 hour yet. No, it's not. Okay. Take a rest for a while. I'll give you a new reaction. Okay. Let me answer John T for a while. Right? So, John T, do you have? Oh, you haven't wrote in anything. You have
I'm doing
no.
electrolysis because I give up.
Okay. I'll give you some educated guesses. Remember, I'm also guessing, right? I think, first of all, the problem will be similar to polymers lah, in general. Polymers in general have problem.
Yeah, but I don't recall like in class, right, what is the pollution caused by disposing polymers. I don't think we learned it, but I'm not sure.
Yeah, wait. I think you're confusing something, John T. You're confusing what you learned in class with the syllabus here. I don't really care what you learn in class. You shouldn't. What you really care is in the syllabus or not. Yeah, no. What's in the syllabus or not, which usually will be tested there. Because the way the examiner treat the syllabus thingy is very different from the non-syllabus thingy. They will assume you know the syllabus thingy.
Prior information.
They don't care whether you learn in class or not. They don't care whether you have seen it or not. Fair, right? That's fair to everybody. What? Now, you're asking the wrong question. You have never seen it in class. The answer is don't care. you need to care whether it's in the syllabus. Now, so far, you have a shortcut called Mila. I keep telling you, oh, this one is the syllabus. That means you have to know. This one not in the syllabus. That means you have to read. But you don't have to believe me. You can check the syllabus. But don't use class as your standard. Don't. Maybe you sleep. Maybe you were sick.
Possible.
Yeah, so don't care. Anyway, you have enough time to care. It's not one day before exam. You understand me? Right? You understand me? Right?
Yes.
So I keep telling you the pollution caused by polymer is in the syllabus. Accept it or check the syllabus yourself because you cannot turn back time and go to your class. Okay, fair, yeah? So that's why I'm giving you, an educated guess. Okay, look, PTFE is also a polymer, keeping it simple. Maybe the problem is just the problem of general polymers. Maybe. That's a reasonable guess based on the situation.
Yes.
Okay, then at least work something out there before looking at the answer key. And at least, write something before you kind of, give up to the answer key. Right? Fair enough. Fair enough. Okay. Write something and then look at the answer key and then we learn something, right? Come, then we'll talk about your distillation and your other stuff, right? Come, try something first. Try something. Okay, then I'm gonna give you. Do you have the periodic table with you?
Yeah.
Okay, if you don't have, go and Google it. But I think it's better to have a physical one. Why? Because MR. We'll be using MR. Okay, we'll be needing MR. Okay, so I'll give you a new reaction which involves solid. Like for example, in your memorization, you should know that BaSO4 is, I cannot use BaSO4. Can use our BaCO3, which is solid. Okay, the question tells you that. Then react it with a simple acid. Then you will have BaCl2, which is aqueous. This is aqueous. And then plus CO2 plus H2O. Okay, this will be gas and this will be liquid. Now, look at page 9. Are you there, Aiden?
Yeah.
Now, this is written in the exam. You must understand one thing. Whatever they write, they cannot mislead you. All these are correct. If something is missing, they cannot give you an impression that is complete. This is an impression of a reaction. Everything is there. So they cannot fool you. Hey, sorry, actually there's one more thing I forgot to mention you're supposed to know. Cannot do that one. Okay, just to be clear. If there is something missing, they have to indicate to you, like for example, with an empty box. Okay. This solid aqueous thingy also, if they give you, it will be correct. If they don't want to give you, they will leave it blank for you to guess. So in this case, it's just given to you. Okay?
Yeah.
Now my question is this reaction complete or are you supposed to do something with it?
It seems complete to me because carbonate plus acid is carbon dioxide, water, and salt.
Correct, which is definitely what you learn, I think, even in maybe secondary 2. However, in secondary 3, the numbers, you usually have to figure out yourself, the number, the ratio. So to do that, they will just put in an empty box or a dash. So they will also indicate to you that, yo, be careful, you still have to figure it out first. Okay. So before we use this reaction, figure it out, please.
When you figure out which one do I start with, because in the class this afternoon, you say like start with something, right?
Correct. Very simple strategy. There are 5 numbers, right? Always start with the substance, which only exists in one thing on the left-hand side and one thing on the right-hand side. Let me give you a good example. Ba, 1, 1, and one substance. Let me give an example of not a good thing. Oxygen, 2 substance, 1 substance. The 2 substance will give you headache, like really headache. So Ba, good. How about Cl? Good or not?
What do you mean by like one substance?
Do you see Cl in any other substance? Any other, in this case, what's the word? Not composite.
No.
No, yeah, you get my point now. So Cl is only in one thing in all left-hand side, is only in one thing in all the right-hand side. Then CL is a good thing to do. BA is a good thing to do. You get what I'm saying?
Yeah.
Just by doing that, you have 3 numbers already. Very happy, very simple. Then figure out the rest after that. Okay? But stick to the easy one, meaning 1, 1, 1, 1. For some strange reason, teacher don't teach that. I don't know why. I have to keep saying this to everybody, and it does make sense. So please do so. Janti, are you looking at the answer key already? That's your educated guess, right? So
yeah, that's my guess.
right. Okay. Again, it's an educated guess. Don't feel too bad. Just learn something from the answer key. What is it? What does the answer key say?
Check now.
All right. And suffice to say, I agree with you, Aiden. You are correct. Any doubts?
No.
Good. Now you can use it. Now you know 1, 2, 1, 1, 1. You can now use the MR mole, whatever they need. Now here's the question, right? So I have 10 grams of BaCO3. It's not in mole, yeah? Okay. So how many dm cube of CO2 will I produce?
How do you calculate MR again?
Oh, look at the periodic table. Simple. Look at periodic. Find Ba, find C, find O times 3, add them up together, done. It's not complicated. You just have to find them though.
I find it and do what with them?
Oh, right. Go and find Ba. Come, find Ba. Where's Ba? Go and find it. It's a big number.
BA is
Group 2, group 2.
group 2.
How is it, John T? How is it? Go and write down. Okay, Aiden. Go and write down. Okay, John T. How is the answer key?
Yeah, I think I find it a bit high.
Oh,
So I went through like all the entire 600 pages. But I don't think I could only find one more. But
you mean the collision question?
yeah, that's why I started doing our chapter.
No. Let me confirm it later. For now, settle this answer key one first. Come on.
Yeah.
Okay.
Okay,
so it will be this guy.
This is so weird.
Then this guy. Okay. The mouse will be a bit troublesome, Aiden, but we'll leave it. So what you do is 1 this plus 6 times 3. Make sense? Make sense or not? This has to make sense.
Oh, okay. Yeah.
That will be the MR. So, you have a very big number MR. Just press your calculator.
Yeah, I'm correct.
Yeah. So surprisingly, John T, even though you don't feel social with yourself, even though, fair enough, you don't feel social with yourself. But hey, it turns out to be correct. Why? Because we use the simple exam rule. What is the simple exam rule? If it is within the syllabus, you're supposed to know. You're supposed to use it. If it is not in the syllabus, they're supposed to tell you something about it, which you're supposed to use.
Makes sense.
Okay. This will always apply to all questions, and chemistry is notorious for importing new things. Notorious because people don't like it. Me, I like it. I just read. People don't like to read lah. People want to do. Don't know why. Okay, John D, I hope this teaches you something about exam skill, not about the topic. Okay. Yeah. Now, do you want me to talk about the electrolysis or the distillation, or look together the pollution
Can you
question?
check part 3 first? Okay, no, actually I can check one.
Yeah, you check yourself. So Aiden, this is an ugly number, right? You don't care. Do you understand me? This is 10 over 197 mole. That's it, look. Do you understand me? No need to convert this to decimal or whatever. It's totally not advantageous, total waste of time, and the result is even worse. I mean, is there a reason why a decimal is better? Something like that. Is there a reason? If you find decimal to be better, maybe you can do that. That's fine, I guess. Do you want to make it the decimal?
No. So
this is fine. This is a fine answer.
Oh, okay.
first of all, this is not the final answer, right? So in final answer, if it's not a final answer, nobody cares. This is the middle of the answer. This is still working. Secondly, a final answer with fraction is totally acceptable. Just saying.
Oh,
Okay. So now, what do you do with this mole of BaCO3? Right? What do you do? They're asking you for, the dm cube of CO2 produced.
it's exactly the same, right? What did you times that? No, times
no. Well, first of all, the mole is exactly the same. It's 1, 1. The mole is the same. You're right. The mole is the same, but then for dm cube times 24, and therefore that's the answer. Tada, finish. Simple, right?
Yeah.
After a while, I mean, to be fair, I mean, how difficult is the whole process? I mean, I would think not really. It's just the numbers are very ugly. That's all.
Yeah.
And the number will stay ugly. I mean, just accept it. It will stay ugly.
Yes.
Okay. Now this is for now the furthest insight I want you to take today. Right? We'll get more insight, but we'll go back to the past one first. I think that's more important.
Okay.
Okay. Now at this point, shall we try a QA question? Do you think it's good? So I'll give you an exam level QA question, and let's see whether you can understand it. Okay. You need all the memorization table, which is to say, don't memorize them. Just put it in front of you if you have them lah. Don't bother memorizing it right now. I know you're good, but we got to use it right now. So use it.
Okay.
Yes.
Does the difference in reactivity between the two metals affect the rate of electrolysis?
Does the difference in reactivity reflect the rate of
because this question is it does not. So
electrolysis
the
depends on
zinc
the
will
rate.
diminish at the same size, no matter what metal.
Yeah, because the rate is dependent on the rate of electron. Remember, electron is the driver in electrolysis, right?
Yeah, but if the difference in reactivity is lower, right, then won't the voltage will decrease, right? That means the electrons are going slower, no?
One more time, you're mixing battery with electrolysis. You're just mixing it, right? I mean, to be fair, when you go to physics, what you're saying makes some sense, but remember, this is chemistry, so I'm not gonna, I'm not gonna take physics in. In chemistry, battery produces voltage. Fair. Battery is cell. Electrolysis requires voltage. So it doesn't matter just being very strict here. It doesn't matter whatever the voltage difference is between the metal in electrolysis. First of all, one of them is not reacting.
Yeah.
So no, the difference between reactivity does represent the voltage difference, but in electrolysis, it doesn't matter. In fuel cell, it does matter, but they never ask that because they know it's a physics question. They know that.
And what is the one difference between
what? Between what and what?
Say state one other observation that will be different from the original setup.
Oh, I'm sorry, you're already referring to the next question. I didn't know that, so I didn't know that. So right. Okay. This is I'm sorry, this is an electric cell. Why did you say that this is electrolysis? This is not an electrolysis. This is a battery.
Yeah, but it's under the electrolysis topic.
Yeah, I know, but electrolysis cell and battery cell is different. This is now battery, not electrolysis. It's not electrolysis. So let me see. Rather than go through the mind, it's a bit of a minefield if you want to go to the rate. The rate is not discussed very well in chemistry, right? So no. So why don't you do something else? Why don't you do something else? Remember that the zinc will react, correct?
Yeah, the zinc will react in both.
So, oh, I'm so sorry. No, nonsense. The new setup, there's no zinc. The zinc is replaced with iron. What are you talking about?
Oh my god, that's copper replaced iron. That's why.
What you reading problem.
Oh, okay. Yeah,
okay, then it's easy to say now, right? Just talk about what happened to the iron, right? Easy, right? Sorry, Aiden.
Iron will, no, but the iron will still diminish, right? It's still iron diminishing.
Iron will react lah, which is
Yeah.
different from zinc reacting. So we just state that as a difference lah. That's all.
That counts as a difference.
No,
But
man.
But observation, right? The observation is the same.
What do you mean? The zinc react? I mean, I know the zinc will disappear lah, and then zinc becomes zinc 2+, which is colorless, right? Now iron will react, iron will disappear, fine, call that a similarity,
Yes.
but when it enters the solution, it is no longer colorless. Hello?
So the difference is that the electrolyte changes color.
Oh yeah, because of the Fe2+ or Fe+, I don't know lah. Just assuming Fe3+.
But you
right?
assume 3+, right?
In general, Fe3+ is easier, and you don't know that. That's outside the syllabus. Just assume it's 3+. Just assume.
Because no, my teacher said that. My
Correct,
teacher
correct.
said, yeah, my teacher said
Correct.
assume Fe3+.
Assume 3+ first. Correct. For
Okay,
reasons
right.
that you don't know lah, right? Okay, so okay, Aiden, what I'm going to do is I'm going to share my Google Drive with you. You have a Google Drive, right?
Yeah.
Okay, you go to your Google Drive, right? Okay, I also have to confirm your email. So once I share with you my physics and my chemistry drive, you'll be able to access the question and use it, to practice lah, right? You're saying? Yes, you're saying?
Yeah, all of the questions.
Yeah, all, which is to say, use it wisely. I almost never ask you to practice more unless I think there's a problem with your school practices. Right? If there's a problem, then I will specifically say from now on, you're not going to care about your school practices because it will come too late, too little, right? But for chemistry, hopefully that's not a problem. To give you an encouraging fact, no matter how bad the chemistry teacher is, no matter how bad, all of my chemistry students will always have the right and good practice one, no matter how bad the teacher. However, that's not true with physics. I don't know why. Physics teacher tend to give too little and too easy practices, and then in exam they whack you. Something like that. Chemistry tend to not do that. Chemistry teachers, no matter how good or how bad, will tend to give you the right proportion of practices very early somehow.
Yeah.
Just like a math teacher is unlikely to give you too little practice. They will give you maybe too many.
Oh.
Have you ever seen a math teacher, no matter how bad, but they never also give you practice? In local school, that's not what happened.
Yeah.
Yeah. So you don't worry about chemistry, but of course, we already know we have to worry about physics. So anyway, let me share you the drivers. Now, I hope with your new chemistry teacher, that will be true. I hope. That is likely, yes. Now, what's your email again? Let me check. What's your email? I need to know your email. I need to get your email. The Chong Saw, how do I copy this? How do I copy? Let me copy your email. That's very long. Oh, great. Aiden, sorry, I have trouble copying your email. Could you just message me your email? It's a bit long, so that I'm not wrong. Help me, maybe WhatsApp or Zoom. Jonty, what are you doing right now? Oh, you're finishing that.
This, I'm dying. What beer? Okay.
Oi, Fe3+ is red brown, not green. Talk. A bit of memorization is.
Yeah, you're right. You're right.
Yeah, you have to memorize it.
Fe2+. You're right.
You have to. Yeah. So take it that green is less popular, than red brown. Red brown is more popular. Okay, good.
It's in the chat for Zoom.
Okay, let me take it. At this point, Aiden, you know that this is not similar to the normal online class. Yeah.
Yeah.
And I feel that you are taking initiative, right? Take more initiative if you want to, right? For example, you're just telling me, oh, wait. I need to make teacher Philip aware that I've sent the message. Good, that is initiative. That is what I think is very good. Now, how do I share with the Google? Okay, there you go. Can share it. Let me share chemistry with you first. Physics can be done tomorrow. Okay. All right, good. Now, I have shared with you the Google Drive. It's called O-Level Chem. Can you find that folder? It's in the Shared with Me section.
Okay.
Go into Google Drive. Go and try to find it first. Okay, John T. Now, what do you want me? Oh, you're doing that.
I'm doing this. Wait, the stuff in the middle like doesn't matter one, right?
In O-Level, yes, it does not matter. Yes, you are right. The only at the end it matters.
Condition. Oh.
Which part of the folder do I look at?
Oh, right. So what is the folder content? For example, the folder contains many things. You can just ignore the combined one. Okay, that's for the combined students, right? But does the year matter? Like for example, 2019, 2018, 17, it does not matter. The syllabus doesn't change a lot. Okay, but the 2019, 18, 17, 14, 16, those are prelim questions. Now, here's my question to you. Can you use prelim question or not?
Yeah, you can, but you should.
Right.
I think.
But how come you as a secondary 3 student can use a prelim questioning? How come you can?
Because you like pick certain questions that the teacher had already taught the topic for.
You're correct. So, and it's good to learn to identify, but more importantly, the assumption is the difficulty level that you face in Sec 3 will not be different from Sec 4. They already taught you everything regarding the topic.
Yeah.
Correct. But does there anything stop you from using Sec 3? No, because usually it's easier to find your topic in a Sec 3 paper. So that's fine also.
Yeah.
So currently you have option. And of course, I think Sec 3 is just easier and I think you won't run out. You probably won't run out. Right? So now you go and should you choose SA1 or SA2? Probably SA1 will have the wait, it's QA. I don't know. Most people don't have QA in SA1. So if you want to practice QA, let's say you randomly choose an SA2 paper. Now you tell me which one you open. You're going to randomly choose one, please, from Sec 3.
Okay.
So you tell me which school, eh?
I open a Gan Eng Seng one.
Gan Eng Seng. Let me go for Gan Eng Seng. SA2 or SA1, just to confirm?
SA2.
Okay. Now you and I are going to try to identify a QA question. Okay. Let's see who find it first. Ignore the MCQ for now. You're going straight to the paper 2 lah. There's a lot of MCQs, isn't it? Okay, let's see whether you can find the QA question. Yes.
Unfortunately, I'm dying.
You are done with the, it's easy for you.
I'm dying. It's very difficult.
Okay, let me help you just a minute.
How come there's a double bond C?
Double bond, wait, double bond C is what? Double bond C is alkene, what? No way. Wait, let me check.
Yeah. Why is it here? Is ester not like this one? Like it's like this.
Okay, look. So for ester bond, again, you don't care about what happens in the middle. You don't care. Now, let me show you where the ester bond is. Now, I hope you can identify. Here is the ester bond. There you go. There, ester bond.
Right. Yeah,
that's the ester bond. Right. So again, what's your problem?
They're asking for what two things react with each other.
Two things. Oh, between A, B, C, D, is it?
No, they give us that they say monomer B was formed by reacting propanoic acid.
With another B, okay.
Yeah.
Propanoic acid. Yeah. So I mean I can hey, you're not paying attention closely now. First of all, this is propanoic, not propanoic. Okay. I'm going to challenge you to try to draw this now. Try drawing this now. You're confused because you didn't draw. Try drawing it. This is a good lesson for you. Okay, QA.
There's no QA in the paper, I think.
There, oh, wait. Let me think forward. Surprisingly, let me think forward. Surprisingly.
Yeah, surprisingly.
Oh, I see.
You
Oh,
see
that's
what I
why.
mean? You see what I mean?
Yeah, see what I
Okay,
mean.
good. Yeah. So you're confused over, not over nothing, but you're missing something. You're missing something already.
So
Surprisingly.
it's just is it just mathing?
Okay, wait.
Yeah, what am I saying? It's not mathing. Okay.
Yeah, even B10 is not QA. Wow. I mean, to be fair, QA question is not always in a separate question one in the end. To be fair like I said, the QA is meant to be used in other topics.
I see.
So it's not always a separate thing. You're saying? Sorry, you're saying?
I was asking like, remember like how like the structure of the paper is like, is it like paper 1 MCQ and then paper 2 open-ended?
That one is always true until O level. So at around end of year, you have enough topics so that they will separate between paper 1 and paper 2. However, most of the time, it doesn't really matter because they do it in the same day.
Yeah, because my current exams in school is like 5 MCQ question and the rest are OEQ in the same paper.
Normal. The MCQ will grow and the short answers question will also grow. That just makes sense.
Oh.
During O level though, so this is a long time. This is 1 year from now. During O level, no, never mind. We talk about O level later, at year 4. For now, whether it's MCQ or not, there will be MCQ and there will be short answer. And in this paper, you see some very long questions, which is part B. That's called the section B. Those are very long questions. Now, long questions will start to appear at the end of year 4. Not by term 3, I don't think so. That is what you need to worry about, not the MCQ. The long questions you do need to worry about, at least for now. Okay, not because they are hard, but because they are hard to understand. So we kind of just learn that. Okay, now never mind. So now let's test something because I still want to know how good or how bad you are, right? Okay, you are so far quite good. Let me know. All these things are no joke question. This Gan and Seng, Gan and Seng. And most of them are serious. Never mind. Let's go to SA1 for. Let's go to SA1. There are very little SA1 question. Let's go to Cambridge, shall we? Cambridge. Let's go to Cambridge for now, right? Let's see whether they'll give you, well, not so tough one. Oh, no. No QA. No. Shuttle. Shells. No. Oh, goodness me. Nobody likes QA questioning. They also don't give you this. Okay. Let's go to MCQ. Okay, I'm gonna do one more. Come on, we're running out of time. Oh, goodness me. Yeah, okay. So anyway, it is as predicted. Most of them are more of the mole question or the acid base and solubility questions with the identity sometimes thrown. That is very normal. And we haven't We haven't started to talk about the acid base and solubility, so I cannot give you that. Now, anyway, for now, today, we have 2 times 1.5 hours, right? Is it too tiring for you?
For me, I'm not sure about that. As long as in like I learn something or like I get better at something, it's fine.
Okay. Is it productive enough then for you?
I think the productiveness is okay.
We'll go higher difficulty tomorrow. Okay?
Yeah.
Okay. Then I'll see you tomorrow at 2 p.m. Okay. Thank you, Aiden. Now, let me get back to John T for now. Right. Okay, John T. Right. Do you want to call the distillation thingy?
Yeah, I don't understand how it works. But like
Right.
it's not important, right? It's just that I also want to know.
So you do this thingy first. Let me draw the
Oh,
distillation.
I'm basically done already.
Okay, good.
Right,
Right,
so there is no change in.
Sorry. Let me confirm that the distillation thing you're talking about is this lah.
Yeah, it's the water in, water out.
All right. Now, I think you're asking the question about the cooler. Okay, so the cooler is a separate tubing outside the internal tube.
Yes.
Okay, you're asking about that blue envelope. Okay, so quite simple. Quite simple. The red one is super hot because that's what distillation means. You're changing something liquid or aqueous into something gas, right? That's what it means, correct?
Yes.
You're supposed to have, a separate gas with, a separate liquid here. You're separating, the liquid number 1 with liquid number 2, and liquid number 2 go and become gas number 2 first. Liquid number 1 hopefully stays down there because their boiling point is different. Am I making any sense right now?
Yes, yes.
Now, the gas number 2 will travel up, and a little bit down here, the condenser will start kind of early here. So I'm drawing it wrongly. The condenser should start around here earlier. Now, the condenser's job is very simple, right? Lower the temperature of the gas.
Yes, correct.
So the gas will then condense again. That's why it's called a condenser.
Yeah, so
and then
basically it's cold, right? Basically the condenser is cold.
Cold come in, hotter water come out, if that makes sense. Yeah, because it's taking the heat from the gas.
Yeah, I know. Okay. I understand that the water gets hotter, but who is telling the water to exit?
Who is telling? Oh, you don't know how it works. Okay, wait. Let me confirm this. Let me confirm one thing. Let me confirm one thing.
I know what it does, and I know how it does it. I just don't understand like how it works.
Okay. Look, now the internal tubing is the red one, right? It's the red one.
Yeah, correct. Then there's water in between, right? Here is water.
So tell me, does the water ever enter the red tubing?
No.
Very good. So the water is encapsulating the red tubing.
Correct.
So they built this blue one very specifically. So basically they just build the blue one and then they kind of make a hole in the blue one so that the red can go in and another hole here so the red can go out. Basically, that's what they do.
Yeah, so it's like a coating.
But a very thick one, like a thick one, because you need a lot of water going through. Now, then I thought that explains how it works. So once you have an inlet here and an outlet there, then the water can go in and encapsulate the red without actually entering the red and then just go out.
But why does the water go out? Like how does it go out here? Why does it go out?
Oh, for example, because there's a pump. You need a pump for this to work.
Simple.
Yeah. You need a pump for this to work. If this works in a lab, you will see that there's a machine somewhere else pumping the water. Confirm. That's confirmed.
Oh, because I've never seen this thing in real life.
Because you don't have a lot. What? You have never.
I've never seen this thing like in real life. I've only seen it in the on paper. Then on paper they don't show you this. They just show you water in, water out. Then it's just 2 holes only.
Oh, I'm very happy to explain to you. Like that's the problem is that the practicals doesn't give you that. That's right. And practicals are not interested in this usually.
Yeah, but the main point is that it just condenses gases, right, in the tube. That's all that matters.
Yeah, that's just cooling gas, correct? That's all.
Okay, can
Good
you
question.
check my answer correct?
Oh,
these two?
gila, permeable propylene acid with methanol. I think that would be correct. Then monomer can use by itself. A very common question, right? And I will agree with you because monomer D has carboxylic and alcohol.
Both the groups. Yeah.
Yeah, but monomer C unfortunately only have the amine, right? Not enough lah, right? The monomer A only have carboxylic, so not enough. And monomer B is by itself can. B can what? How come you didn't include B in your
Because
answer?
they say by condensation.
Oh, you are absolutely correct. Thank you very much. Good. Reading. So weight of these monomers will undergo without a change in percentage composition.
I'm trying to say like that
right.
they don't lose any elements. Like nothing is lost.
Then you just say that. Yeah, because monomer B will process addition, which is wonderful, and it's not external product of form. That's the wrong phrasing. You already have the right idea. No small molecules are
lost. Or can I just say the chemical form? What is it called? Chemical formula.
The chemical composition, before and after is the same, right? Before polymerization and after polymerization, the composition is the same, because there is no small molecules ejected. That's actually an acceptable
chemical
answer.
Composition remains
before and after remains the same, right?
Is this okay?
Because no small molecules are lost, or maybe we just change it to ejected, which is what happened in condensation. So of course you have the right idea. I hope this reinforces your OChem, right? Okay, you're not perfect, but you're comfortable. You're actually quite comfortable with pollution right now. Quite comfortable lah. There's definitely improvement. And we haven't practiced section B, but I don't think that's the problem right now. Good. It's a good improvement.
I wanna revise ammonia for next exam.
Ammonia should be fast unless you are, you're a lot of gap. No problem. I like that. Any other thing that you want to revise? Think about it.
So like last time I was trying to revise blast furnace, right? But then I searched online, right? The equation very there's like 1,000 of them.
Revising what? Sorry?
I revised like OChem, right? I mean not OChem. I was revising like the blast furnace. Then like I searched online, right? I got like 1 billion equations.
Blast furnace and OChem. Sorry, what's happening here?
No, not OChem. OChem I say CCR. Go page 14.
Page 14. Right. Blast furnace, you only have.
I was trying to revise blast furnace. Yeah, but I then got like 1 billion equations. Yeah, like not all of these are important, right?
Yeah, you just have to worry about 5 lah. Which 5?
Yeah, which 5?
This one. So it's all this one and this one. So this is number 1. This is number 2. Then this is your
Fe3O4.
This is your number 4. Then this is your number 5. Right?
Where is 3?
3 is the most important one.
3 is this
and
one.
That's where you produce a.
No, it's not.
Now, normal. No, it's not. The final one must produce an Fe, right? It must produce an Fe. So, unfortunately, usually they will choose to write the hematite because they mentioned hematite as an example. Hematite is this one. So, in the end, it has to be this one. No?
But then how come they have these two here?
Plus CO2, because the original iron ore is never just a mixture of hematite. It's a mixture of these 3 things at the very least someone. This one, this 2, and this 3. So he is correct now, of course. He's more realistic. The syllabus simplifies it to just one guy, which is this guy. And he bypassed this. Bypassed this thing. He doesn't go from here to here. He just go from here to Fe. In reality, it's true. That is not what happened. But the syllabus say, don't care, just shortcut. Okay, so use the shortcut. Use the shortcut.
Okay.
This is of course more interesting. You can ask reason why, blah, blah, blah. Yeah, I mean, I can tell you the story lah, but you know, for syllabus purposes, you need to
Not
know
needed.
this. Yeah, and you need to balance it also, by the way. I
Or-
usually don't bother with the memorization of balance. I just balance it.
Memorize the
in-
equation, it balance after.
I would prefer to do that. I would prefer to do it rather than get the balance wrong, because you know I'm not that good in memorizing. I'm not that good. The chemistry paper is between A math. Yeah, so I don't think I want to bother to memorize too many things. It's A math, chemistry, A math.
Okay. Okay.
No. Wait, what? No, sorry. It's E math, chemistry, E math. So that's not that bad. It's not that bad. Good. Yep, that's it.
Yep.
Okay, I
Okay.
will see you next week. Good job, Junti.